In this video, we'll be considering 33 important background ideas of 2024 AIME 1. We'll be solving all problems, and also I leave 32 similar problems as homeworks from AIME, past years of AIME, AMC, PMO for Philippines, SMO, Singapore, similar problems. We'll be considering these ideas and stars and bars, drawing the graph, drawing perpendiculars, hyperbola, calculating limits by using long division, Ceva's theorem, ratio lemma. They are so much important. Length of median squared, which function is on top of the other function, the ideas are what. And binomial expansion in mod, these ideas. For example, new form of Heron's formula for calculating area, Lagrange multiplier, factor theorem, Inradius formula, and also in 3D. The problems are these. We'll be solving like this. At the end of each problem, I will leave some homeworks like this. Similar problems. Okay, so all problems like this. Okay, if you had any question about the problems or wanted to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description. Problem 1. Every morning Aya does a 9-kilometer walk and then finishes at the coffee shop. Okay, so let's here, because we want to work with distance, with speed, we should work with this formula. V is equal to D over, because here we have small t, right, big T. Speed is equal to distance over time. Is first formula that is important. You should know in AMC also useful. Or we can say distance is equal to V times time. One day she walks at S kilometers per hour. Okay. And the walk takes 4 hours, including 10 minutes at the coffee shop. So here it means what? This distance is what? 9 kilometers, and speed is what? S. So we can say 9 is equal to speed is S, time is what? Here it says 4 hours, this part, including 10 minutes at the coffee shop. So here, if you want to see from here to here before coffee shop, it will be what? It will be 4 hours minus t. 4 hours minus t here, and here t minutes in our coffee shop. Okay, so it will be 4 minus t, what we consider t in hours. Okay, so 4 minus t, and so for t we consider hour. Another morning she walks at s plus 2, so it will be s plus 2, and time is what? 2 hours and 24 minutes, again including 10 minutes at the coffee shop. So 4 hours and 24 minutes, 2 hours and 24 minutes is 2 plus 24 over 60. We want to change it to hour. If you divide by 12, it will be 2 over 5. So it will be 2 plus 2 over 5. If we use common denominator, it will be 10 plus 2, 12. 12 over 5. So time is 12 over 5 minus t. Okay? So we are applying the formula before coffee shop. Okay, from the beginning before coffee shop. Why? Because in the coffee shop we don't have any speed to apply. So that's the reason you say, okay, 12 over 5, it says including 10 minutes in coffee shop, so we subtract t. And we said we consider t, the units of t in hours. Now it will be what again? 9. So two equations, two variables, we can find s and t. The last part, it says if she walks at s plus 1/2 kilometers per hour, again distance is 9, speed is s plus 1/2. Then it says how many minutes? On this part is minutes. So at the end we should change hour to minutes, including the t minutes at the coffee shop. So here we consider this one big T, and the answer will be what? Will be big T plus a small t. Okay, big T is until coffee shop and small t in the coffee shop. So now let's solve these three equations. Let's apply this part. Okay. So if we multiply, here we can say what? Here we can say, we can use replacement. Okay, first we want to find s. So if you divide by s, 9 over s is 4 minus t. Then we can say t is what? 4 minus 9 over s. Now, if we replace t here, it will be 9 is equal to s plus 2 times 12 over 5 minus t, which will be minus 4 plus 9 over s. Now, if we simplify, it will be s plus 2. 12 over 5, let's write 9 over s. If we use common denominator, 12 minus 20 is minus 8, so minus 8 over 5. Now I want to get rid of denominator, so I multiply by 5s. 5s times 9 is 45s. This one is s plus 2. If we multiply second bracket by 5s, first one is 9 times 5, 45. Next one is minus 8s. Now, let's multiply to see what we can reach. 45s is equal to 45 times 8 is 45s. 45 times 2 plus 90. Minus 8s squared. Minus 8s times 2 is minus 16s. We can simplify this. We can take all things to left hand side. So it will be 8s squared. And we can divide also by 2. So 4s squared plus 8s minus 45 is equal to 0. Now here you can factorize or you can use quadratic formula. Okay? So quadratic formula is what? If we have ax squared plus bx plus c equal to 0, then x is equal to negative b plus minus square root of b squared minus 4ac all over 2a. Now here we can say s is equal to negative 8 plus minus square root of 64 minus 4 times negative 45. 4 times 40, negative 45. Negative negative will be cancelled. 4 times 45 is 180. 4 times 180 is 720. Over what? Over 2 times 4, 8. Now here we can say it's negative 8 plus minus 64 plus 720, 784. And square root of that is 28 over 8. Negative is not possible because s cannot be negative. S is the speed here, 28 minus 820 over 8. If we divide both numerator and denominator by 4, it's 5 over 2. Kilometer per hour. Now it is our s. So let's find small t. A small t was what? 4 minus 9 over s. 4 minus 9 over s is 9 times reciprocal of 5 over 2, which is 2 over 5. Which will be 4 minus 18 over 5. Which will be 20 minus 18, 2 over 5. Okay? So it is a small t. Big T is what? Big T we should use here. This one. S is what here? We proved that S is 5 over 2. So 5 over 2 plus 1 over 2 times big T. 5 over 2 plus 1 over 2 is 6 over 2, 3. 3t. So big T is 3. So we call this one 1, this one 2. So it is what? It is big T is 3. Small t is 2 over 5. And because we want to change it from hours to minutes, we should multiply it by 60. We can multiply 3 times 60, 180. 5, 60, 12. 2 times 12, 24. So the answer is 204. Okay. Our answer is this. And in all of these problems, you should use this formula. Okay. Also in AMC. So if you want to learn similar problems or if you want to solve harder problems from this type in AMC AIME, as I said before, feel free to send message to my WhatsApp number in the description. Problem 2. It says real numbers x and y with x and y greater than y satisfy log y to the x to the base x is equal to log x to the 4y to the base y is equal to 10. What is the value of x? When we see logarithm problems, let me see, it will be which idea? Idea 3. We have two approaches. then we see logarithm. One approach is to use rules. Another approach is to change it to powers. Means what? When we have, for example, log a to the base b is equal to n, it is equivalent that b to the n is a. Sometimes both of them useful, sometimes one of them is makes the problem so much easier. I think in recent years of AIME, we had one problem that you should change it to this. Change it to powers. Here again, we can do the same thing. Log x to the log y, this one. Log y to the x to the base x is equal to 10. Let's consider this. It means what by this definition? X to the 10 is y to the x. If we apply for this one equal to 10, we can conclude what? Y to the 10 is equal to x to the 4y. Now here, we want to find value of xy. So if we calculate, you can see y to the x will be x to the something, then x to the y we know is y to the something. So we can say y to the xy is what? We can write it as y to the x. To the y to the x is what? X to the 10. To the y. From here, you can switch y and 10 x to the y to the 10. From here, if you divide by 4, if you divide powers by 4, it will be y to the 5 over 2 is equal to x to the y. So it will be y to the 5 over 2 to the 10. So 5 over 2 to the 10, you can multiply 525. Y is greater than 1. So when y to the xy is equal to y to the 25, the powers are equal. So xy is 25. So we've solved this problem like this. We can write also this one. If a and b are positive real numbers, and we can say if a to the x, or let's say, for example, c to the a. Let's consider only one of them. A is positive real number. Then if a to the x is equal to a to the y, then we can conclude x is equal to y. Why we have this? Because if a is greater than 1, it is strictly increasing. If a is less than 1, it is strictly decreasing. Less than 1, greater than 0. Okay? And a shouldn't be 1. So a should be positive real number and a should be greater than 1. Okay? Or let's say a is not equal to 1. And this problem, because it says y, the base, like here a. Y is greater than 1, so it's not 1, and we can conclude the powers should be equal. If you want to know important rules in logarithm, around 10 important rules, as I said before, feel free to send message, my WhatsApp number in the description. Let me tell you some similar problems for problem 1 and problem 2. Okay, for problem 1, you can solve first problem of AIME 2 2018. Let's write this one as homework 1. For problem 2, let me tell you exactly similar problem that you should apply exactly same approach. Sometimes it is so much better to apply to change it to power. As homework 2, we can say similar problem. It is for AIME 2, problem 4 of AIME 2, 2022. Okay, if you want to solve more similar problems, you can send message my WhatsApp number. Problem 3. Alice and Bob play the following game. A stack of n tokens lies before them. The players take turns with Alice going first. So this part is important. On each turn, the player removes 1 token or 4 tokens from the stack. The player who removes the last token wins. Find the number of positive integers n less than or equal to 2024 such that there is a strategy that guarantees that Bob wins regardless of Alice's moves. Okay, so this problem is related to game strategies. We have 4 important ideas in game strategies that you can solve problems in AIME, USAMO also. I solved last USAMO and we had similar problems. So let me tell you these 4 ideas. One of them is invariant. One of them is n and w of n. Here we want to use this one. Third one is symmetry. I can say we can solve 90% of the problems in game strategy by one of these ideas, and at the end I will tell you some similar problems. And fourth one, going to the end of the game. At first you think, okay, for example, end of the game. Idea 4, so it will be which idea? Idea 4, idea 5. You say, okay, fourth one, this one, it's obvious, but we can solve some problems that are so much hard and you can't solve with any other strategy. So let's focus on this part. Let me explain for you. It is what? I told you the most useful idea is considering a small example. Okay. So here we want to combine this idea and this idea. So let's draw a table and I want to find the pattern. And we can also prove it. But here 1 and 4, these two numbers, in some problems, for example, we have 1, 3, 8. This one is harder than this one. I want to tell you how you can fill this table quickly. W of n means what? Means who is winner. N is what number of tokens. For example, for n1, who is winner? First player or second player? First player, because first player takes 1 token. Then we have 2, who is winner? Second player, because first player can take only 1, second player takes the last one. 2, sorry. Third one, who is winner? First player takes 1, then second player, then first player. So third player is 1. I will tell you how to calculate these quickly. Let's fill some of them together without any idea. For 4, who is winner? Because of these 4, first player. For 5, who is winner? From this part, it's a bit hard to check. We can write all cases. For example, 5, first player can go to 4 or can go to 1. In this case, second player takes the last one, so this one is not good for first player. For 4, we know second player is what? Second player can go to 3. And can take all of them. Can take, and second player will be winner. Okay? So again, these two things are bad for first player to start. So in both cases, first player will lose. So here, second player. Let me tell you, I want to generalize this idea. Suppose, for example, we are in position 1 and we can go to x1, x2 to xk. We want to see under what case. In position y, for example, here, w is 1, first player wins. In what condition? Second player wins. So if w of one of them is 2, it will be good. Like what? For example, for 6. For 6, first player goes to 5. Why? Because in 5, the player that starts will lose because w is 2. So first player goes here, and in this kick part, first player doesn't start. Second player starts and will lose, so first player wins. Now here, if w of one of them is 2, here why first player couldn't win? Because w of 4 was 1, w of 1 also was 1. Both of them were 1. So in both cases, the player that starts will win. Second player starts here, because first player, for example, here goes to 4, then second player starts. So if all of them, all w of xi is equal to 1, then we can say here is 2. If there exists, or you can show this with this sign, or this, there exists w of xi that is equal to 2. Then we can say here is 1. So Now it is so much important, this idea. Let me move it down. And by this idea, we can fill the table so much fast. So let me move this. It was one of the most important idea in game strategies. So for 6 goes to 5, W is 2, so it is like this one. There exists something that W is 2. So 6 is what? 6 is what? 7. 7 can take from 7 1 or 4. Both of them are 1. So it will be like this one. So W of 7 is 2. For 8, we go to this one, 1. For 9, we can go to 5. W is 2, so here is 1. For 10, if you take 1 or 4, you can go to these two things. So it will be 2. For 11, W is 1. For 12, take 1 or 4, both of them 1, so this one is 2. 13, 1, 14, you can go to 10 by taking 4 tokens. It will be 1, and now we can find the period. 1, 2, 1, 1, 2, 1, 2, 1, 1, 2. And we can easily prove by induction that why the pattern is this. Okay? So, here it will be what? It says 1 to 2024. We know 2020 over 5, we have these number of boxes. And in each of them, it says how many of them Bob wins, means second player. In each box, we have 2 2s, so we multiply by 2. Then 2021 is similar to this one, 2022, 2023, 2024, finished. So is last part. Now if you divide by 5, it will be 404. So it will be 808 plus 1, 809. So we solved this problem completely, but let me prove this for you and let me tell you some similar problems from different exams. For this one, let me tell you the proof. My claim is what? Look, because the pattern, the length of this period is 5, we want to prove W of n is 2 if n is, the remainder is 2 or 0. If n mod 5 is 0 or 2. Otherwise, it's 1. I want to prove this claim. And we can consider, okay, we proved 1, 2 to 5k, and now we want to prove 5k plus 1, 5k plus 2, 5k plus 3, 5k plus 4, 5k plus 5. Okay, by induction. And base case is what? Base case is 1 to 5 that we've proved in our table, and I explained. You can explain it in 2 lines, the things that I said. So base case will be what? Will be 1, 2, 3, 4, 5. Now we should use, let's call this lemma. Okay, now we want to use this lemma. This lemma also useful for proving. For 5k plus 1, we want to prove who is winner. 5k plus 1. We want to prove first player is winner. So we know 5k because of this. Here we can apply induction. For 5k, W is 2. So 5k plus 1 goes to 5k. And W of 5k is 2. So by lemma, we can say W of 5k plus 1 is 1. So we prove first one, and you can prove the rest like this. For 5k plus 2, we want to prove it is 2. So 5k plus 1, 2 can go to what? Can take 1, 5k plus 1, or can take 4, 5k minus 2. So it will be 5 times k minus 1 plus 3. The remainder is 3. W of this one is what? Is 1. Here we W of this one by induction. The remainder is 3. If we check our claim, W is what? W is 1 again. So if we check our lemma, we said if W of all of them is 1, here, W of all of them are equal to 1, so W of this one is 2. So W of 5k plus 2 is 2. Okay? So we prove this for 5k plus 3. For 5k plus 3, you can easily say that it goes to 5k plus 2. W of this one is 2. So again, by lemma, we can say W of 5k plus 3 is equal to 1. 5k plus 4. 5k plus 4, if we go to 5k, W of 5k by induction is 2. Okay? Because the remainder is 0 and we've considered here. So by lemma again, we can say W of 5k plus 4 is 1 again. The last one, 5k plus, you can take 1 or you can take 4. It goes to 5k plus 4 or 5k plus 1. 5k plus 4 W is 1, 5k plus 1 W is 1, both of them. In both of them W is 1, so by applying lemma, we can say W of 5k plus 5 is 2. So we said only in these cases W is 2 here and here, when the remainder is 2 or 0. So we proved this by induction. Let me tell you some homeworks. I told you 2 homeworks so far. Homework 3. Exactly, solve this problem, but instead of 1 and 4, suppose in each step you can take 1 token or 3 tokens or 8 tokens. Okay? And the length of period of this is longer. And again, you can prove like this. Let me tell you homework 4. It is a problem from sample problem of CSAT. CSAT is for Cambridge. Okay, so Cambridge. Let me tell you the problem is what? Okay, the problem is this one. Okay, this one is a bit harder than AIME problem, but similar problem. Okay, so I told you 2 similar problems. And for this problem, now we focus on only n and w of n. And in some problems, you should apply w of n, for example, for 2 dimensions. Okay, I know a problem that is so much hard with this, but you can solve only by using this idea. If you want to know that problem or want to know how to solve problems with these 3 ideas, as I said before, feel free to send message to my WhatsApp number in the description. Okay, let me tell you one more similar problem, homework 5. It is again related it is from AMC 12B 2021. And this problem is for spring. You can try this one. It is not you should use this idea a bit and also other ideas. Okay, here for example a bit symmetry and something like that. And going to the end of the game, we can use these ideas. So you can try also this problem as homework. I can say the difficulty of this problem is similar to difficulty of problems in AIME. Also, I can say this problem is a bit harder than this problem. Okay, so you can try also this homework 5, and if you want a hint or wanted to learn more things, as I said, you can send message. Problem 4. Jen enters a lottery by picking 4 distinct numbers from S1 to 10. 4 numbers are randomly chosen from S. She wins a prize if at least 2 of her numbers, this part is important, at least 2 of her numbers were 2 of the randomly chosen numbers and wins the grand prize if all 4 of her numbers were the randomly chosen numbers. The probability of her winning the grand prize given that she won a prize is P over Q. So grand prize given that what she won a prize is what? We want to calculate this. So let me tell you something. What does it mean? P of something given by, for example, something else. So here, for example, suppose, let me explain for you first the formula. P of A given B, we call this what? Probability of A intersect B over probability of B. Let's see why it is correct. So suppose we want to go, for example, to one of these things, okay? And the probability of each of them is 1/3. So suppose, for example, A is the probability to reach this part, okay, is what? 1/3. Now suppose B, we know B is what? B is these two destinations. We want to say, suppose that we know we reach to this destination or this destination. Under this case, probability of A is what? P of A given B. So you say, okay, because we know B is satisfied, we go here or here, the probabilities are equal, so the probability of A in this case given B is 1/2. Okay, so we can say what now? Let's see, this formula says what? P of A intersect B over P of B. P of A intersect B is A, so this part is what? 1/3 in general. P of B is what? 2/3. So it will be what? 1/2. The reason is what? It says we know A given B, probability of A given B. We know B happens, okay? And now, for example, suppose A is this. Because we know B happens, so we know we are in this case, okay? And then it says, okay, we know given B, what's the probability of A? So you should consider this probability over this blue part. So P of A intersect B over probability of B. It is the explanation of this. Now, sometimes, for example, P of B given A is easier. So we want to see what's the relationship of P of B given A and P of A given B. The formula is what? You say, okay. P of B given A is what? Is P of A intersect B over P of A. So you can say, okay, we can write it as P of A intersect B over P of B, because we want to relate it to this one, times P of B over P of A. So it will be P of A given B times P of B over P of A. So we have this formula. Now we want to apply this formula here. We say, okay, the problem says P of G given P is what? P of G given P, why we want to use this? Because we know easily that P of P given G is what? So obviously it is 1, because when we have, for example, grand prize, so obviously we have also a price, because grand prize is a special case of price. So if we use this formula, it will be P of P given G here times P of G over P of P. Okay, now let's apply. Because this one is 1, it will be P of G over P of P. So we should apply this. We have 1 to 10. It says P of G. P of G is easier to calculate. So let's calculate P of G first. Our numbers are what? 1 to 10. And it says, okay, we have 4 numbers, for example, A1, A2, A3, A4. And we want to see how many numbers in P of G. Let's focus on P of G. Our 4 numbers should be same. So you say what? Because it says we select 4 distinct numbers, okay? And again, when we want to select 4 numbers also are randomly chosen from S. Okay, let me also write the name of this theorem. Idea 7, this part, we can say this part, that it is equal to this, we can say Bayes' theorem. And I will tell you some homeworks after solving this problem related to Bayes' theorem. Now, here probability of G is what? We have 4 numbers and we want to find in how many cases all of our 4 numbers are equal to this. So only one case. So P of G is 1 over what? What are all cases for selecting 4 numbers? 10 choose 4. Okay, we don't need to calculate 10 choose 4 because we can cancel when we calculate P of P. So for P of P, it says at least 2 of them should be same. So A1, A2, A3, A4. So 2 of them or 3 of them or 4 of them. So let's calculate for each of them. Again, we can divide by 10 choose 4. If two of them are same, so you say 4 choose 2. Because we are selecting 4 numbers, we should select 4 numbers. So from the rest, 6 choose 4. 6 choose 2. Because there are 10 numbers, 4 here, 6 outside. So let me say this part. So from others, when you select 2 from here, 2, 3, 1, 4, 0. So 4 choose 2 times 6 choose 2 plus 4 choose 3 times 6 choose 1 plus 4 choose 4 times 6 choose what? 6 choose 0. Now we should calculate this part. Then we have what? We have P of P, and we can divide. Okay? So, if we calculate this, 4 choose 2 is 6. 6 choose 2, let me write 6. 6 choose 2 is 15, so it will be 90 plus. 4 choose 3 is 4. 6 choose 1 is 6. 4 times 6, 24. 4 choose 4 is 1. 6 choose 0 is also 1 plus 1. And over 10 choose 4. 90 plus 24, 114, 115. Over what? 10 choose 4. Now let's divide. P of P of G is 1 over 10 choose 4. Next one is what? 115 over 10 choose 4. 115 over 10 choose 4. And if we divide, if we cancel, it will be 1 over 115. The problem says calculate it like P over Q, they are relatively prime. And P plus Q is what? So, answer is what? It is P over Q in the simplest form. So P is 1, P plus Q. Q is 115, so the answer is 160. I've told you 7 ideas so far and 5 homeworks. Let me tell you 2 homeworks for this problem. Homework 6. Okay, you can solve these 2 problems as homeworks. 2021 Fall AMC 10B. You can solve these problems with base also. You can solve them without base theorem. Okay, so we're getting good at base. We can also try base theorem, how to apply on these 2 problems. Okay, so we solve this problem, problem 4. If you want to solve more problems from base theorem, as I said before, feel free to send message. My WhatsApp number in the description. Problem 5. Rectangles ABCD, ABCD, and EFGH. EF, so let's write EFGH are drawn such that DECF are collinear. So DECF are collinear. ADHG, ADHG all lie on a circle. So let's draw them. ADHG. Okay. It's cyclic if BC is 16. BC is 16. AB is 107. FG is 17. FG is 17. And EF or HG 184. And now it wants CE. Okay, so let's consider this length X. Because we know it is 107, so this one is what? Is 107 minus X. This one is what? We know this length is 184. So it will be 373, 77 plus X. Okay. Now when you see a geometry problem, it's good to, for example, work on similar triangles if possible. Let me tell you, it will be what idea? Idea 7, idea 8. And because it is cyclic quadrilateral, let me draw a better line. We have 4 main rules for cyclic quadrilateral. Okay, so idea 8, we have 4 main rules. They are what? For cyclic quadrilaterals. We want to use one of them. If we have a cyclic quadrilaterals and it is equivalent, you can say ABCD is cyclic if and only if sum of opposite angles equals 180. Okay, so if and only if A plus C is 180. The proof is not hard. You should prove. You should know inscribed angle. You should prove from this part to this part. And from this part to this part, you can prove by contradiction. Now, if this angle is alpha, this angle is what? 180 minus alpha. But because it is 90, so this small angle is what? It's this, it is x. This angle is what? 90 minus alpha. Okay, 90 minus alpha plus 90. 180 minus alpha plus alpha, 180. Now, here we can see some triangles that are similar. Because it is alpha, here it is 90 minus alpha, so this angle is alpha. Okay, this angle. Now alpha, this one and 90 degree. So this one we have alpha, so we want to create, so here also you can say 90 minus alpha, here you can use similar triangles. Or we can extend here, we can extend AD and this part. Then we can say what? We can say this big triangle is similar to this triangle, okay? So, we know AD is 16, HD is what? 17. Here also it is 17. Now, let's consider these similarities. So, idea 9. When you see problems like this, try to use angle chasing. Let me tell you some approaches. Angle chasing. Find similar triangles. Find congruent triangles if possible. By these approaches, we can solve, I can say, most of the problems in AMC, also useful in AIME. So we can say which two triangles are similar. We can say triangle GHA is similar to triangle HDE. Okay. And we want to find what? We want to find at the end. Also pay attention to sentence. We want to find C, which is 107 minus X. So we should find X. So here, by this similarity, X in in HDE corresponds to what? It is opposite to alpha. Opposite to alpha is this one. 17 plus 16, 33 is equal to what? 17. Opposite to 90 minus alpha. 90 minus alpha is this one. Let's write this one. X 184 plus X. Finished the problem. One equation, one variable, quadratic equation. You can find X, and when you find X, you can replace here. And probably because it says what is the length of CE, and we know answers are integers. So you can solve this quadratic equation by factorizing. If you couldn't, you can apply quadratic formula, which I told you, I think in problem, let me see in problem, yes, in problem 1. Now, let's apply. So x squared plus 184x, and if we cross multiply, it is equal to 33 times 17. And let me tell you something. When you want to factorize, don't multiply that, because maybe this factorization is useful for factorizing. Why? Instead of 33, we write 3 times 11 times 7 is 0. Now 11 times 17 is 184. 187. 187 minus 3 is 184. Okay, so you can say x, because it is negative one of them, plus one of them minus, because this one plus, so you should say 187 minus 3. Now it will be good. Because x is positive, this one cannot be 0, so this one is 0. It means x is equal to 3. Now we can say CE is what? C is what? Is 107 minus x, which is 107 minus 3, which is 104. As homework, you can solve this problem of AIME as homework 8, AIME 1 2021, problem 2. Again, here you should use ideas that we've used here. This problem was easy problem. We used only two similar triangles. Okay. If you want to know, there are 40, 50 important ideas in geometry. If you want to learn them, As I said before, feel free to send message to my WhatsApp number in the description. Problem 6. For this problem, we should use the stars and bars. It says consider the paths of length 16 that go from the left corner to the upper right corner of an 8 by 8 grid. Okay, so suppose that lower left, upper right. And we want to go from A to B. And it says the path, this is the paths of length 16, this part important. And it says find the number of such paths that change direction exactly 4 times. Okay, so in first step, we can go to the right or to up. So we can say what? Because of symmetry, we can multiply by 2, and without loss of generality, suppose our first movement is to the right. So, for example, suppose it has some length, and then suppose we have this, and then we have what? We have this part. Because the length is 16, we can say that we should consider minimum paths, because here when you go like this, it will be 16, okay? So if you go to left or down, the length will be greater than 16. So here, 1 change in direction, 2, 3, and 4. So here we consider x1, x2, x3. And here y1, y2. We know x1 plus x2 plus x3 will be what? Will be 8. And they are positive integers. xi are greater than or equal 1. y1 plus y2 again is 8. And yi are at least 1. So if we don't know stars and bars, let's solve this without using that. I say, okay, here, how many answers are there? We can say y1 can be 1, this one 7, because they are positive integers, 2, 6, 2, 7, 1. So 7 cases. For this one, if x1 is 1, the sum is 7 for these two things. So it will be 1, 6, 2, 6, 1. 7 cases. If it is 2, the sum of these two numbers will be 6. 1, 5 to 5, 1. So, sorry, 6, 1 to 1, 6, 6 cases. 5 cases, 6 plus 5 to 1. So 1 to 6 is what? Is 6 times 7 over 2, which is 21 for each of these 21 cases. We can consider each of these 21 cases with each of these 7 cases. Okay, so it will be 21 times 7, which is what? 147. And here we said we should multiply by 2. So answer will be what? 2 times 7, 14. We have 1, 2 times 4, 8. Plus 1, 9. And 2 times 1, 2. So our answer is this. And let me tell you something. If you want to solve it with the stars and bars, homework 8, idea 8. So idea 8, idea 9. Idea 10 is what? Suppose we want to solve, for example, for x1, x2, x3, 8. We said, okay, we have 8 stars, 1, 2, 3, 4, 5, 6, 7, 8. And because we want to split into 3 parts for x1, x2, x3, so we need 2 dividers, 2 bars. This one for x1, this one for x2, this one for x3. So in how many places can we place these 2 bars? We cannot place here. But why? Because x1 will be 0. Here, we know that x are at least 1. We cannot place here. Why? Because x3 will be 0. We cannot place in same positions. Why? Because x2 will be 0. So we should place these 2 bars in 2 different positions here. It will be 7, choose 2, which is 21, like this. And in general, if I want to generalize it, x1 plus x2 to xk is equal to n, and xi are positive integers. Here we have n stars and k minus 1 bars. So it will be n minus 1 places for k minus 1 bars. It will be this. Okay, now there are some techniques around 4 important things. Sometimes we should solve instead of equal to n less than or equal to n. Sometimes xi are, for example, greater than 5, one of them x2 greater than -10. Again, another idea, sometimes you should solve for these things, x1 less than 8, x2 less than, for example, -3, and something like this. If you want to learn all important ideas in stars and bars, as I said before, feel free to send message to my WhatsApp number in the description. So you can solve this problem of AIME 2011 AIME 2 problem 7 as homework 9 with similar idea. Okay, problem 7. Find the largest possible real part of this. So for this problem, we should replace z with a plus bi. Okay, because we want to work on real part and we should maximize what? We should maximize a. Now also we know length of z is 4. So by Pythagorean theorem we know that z squared is a squared plus b squared is equal to 16. Now let's replace here. It says find the largest possible sorry. Find the largest possible real part of this term. Okay, so let's calculate this. 75 plus 117i over times what? A plus bi plus 96 plus 144i over z, a plus bi. I want to get rid of denominator, so I should rationalize it, something like rationalization. A minus bi. Now, it will be what? A plus bi times a minus bi. By the identity of difference of two squares, it will be a squared minus bi squared, because I squared is -1, so it will be a squared plus b squared. Here is 16. So denominator will be 16. And it will be what? 75 plus 117i, this part, times a plus bi, times, because this part is 16, the product here, we can divide. This one will be 6, this one will be what? 9. So it will be plus 6 plus 9i times a minus bi. And here we should focus on only real part of this. Let's define it as c. Real part of c is what? 75 times a, and it says find the largest possible real part of this. Okay, 75a, 117, so this one times this one times this, which will be negative 117b, 6a plus 6a, and this product will be plus 9b, okay, because I squared is -1. So if we simplify, it will be 81a minus 108b. Now we want to maximize, find maximum of this. Here we can factor from 27, it will be 3a minus 4b. So we should find maximum of this. Under what condition? A and b are real numbers. A squared plus b squared is 16. We want to find maximum of 3a minus 4b is what? Let me tell you how we can find maximum of this. There are lots of ways. Lagrange multiplier, derivatives, replacement. I want to use drawing the graph. I told you how many ideas? 10 ideas, idea 11. Also before exam I said this. Idea 11, drawing the graph, and I solved one AIME problem with this idea. So here a squared plus b squared equal to 16. Let's change it because I want to draw the graph. I can say it is ab, or we can change it with x and y. X squared plus y squared is equal to 16. And we want to find maximum of 3x minus 4y is what? Okay. X squared plus y squared equal to 16. It is equation of a circle with center what? With center 0, origin 0, 0, and radius is 4. Okay. In general, when we have, for example, x minus x0 squared plus y minus y0 squared is equal to r squared, radius is r, and center is x0, y0. Okay. So it is 4. Now I want to find maximum of this, means on this circle, for which point this expression will be maximum. Now, suppose 3x minus 4y is equal to k. It is a line. We can say what? We can say, okay, for this one, when x is 0, we want to find y-intercept. Y is what? Negative x0. Y is negative k over 4. When y is 0, k is what? K is, x is what? X is k over 3. When we can consider k is positive, okay? Because, for example, for this one, it is what? 3 times 4, 12 minus 0. K can be greater than 12 because we want to find maximum of k. So x is k over 3, y is this one. Now we can say what? We can say, okay, it is a line. And when k is positive, it means that, for example, you connect k over 4, something like this. K over 3. Okay? X is k over 3, y is k over 4. It's something like this, because this one should be larger than this. Now, we want to find maximum of this. So, and the slope of this line is what? You can say, okay, 4y is equal to 3x minus k. So we can say y is equal to 3 over 4x minus k over 4. So the slope is what? 3 over 4. Now by this slope, if we, so we have some parallel lines. Here I'm explaining, but after solving some problem, you can imagine all these things. We have this. So which of them is better? We have all these lines. So as you can see, we want that k be maximum. And this point is what? Is k over 3, x-intercept. So we want to find maximum of x-intercept. So the best one is what? The best one is when you consider this one. Okay? And it is the line that we want, and it is the point that we want. Okay? Now, if we find this point, the problem will be solved. This xy is good. For x, y, a, b, we can replace here and we can find the answer. So we should find equation of this. So here we said the slope is 3 over 4 also for this one because they are parallel lines. Now I connect what to what? Origin to this point. We know this angle is 90 degrees. So these two lines are perpendicular to each other. So because the slope is 3 over 4, we can conclude that the slope here is what? Their product should be negative 1. So because it is 3 over 4, it should be negative 4 over 3. So for this line, y is equal to negative 4 over 3x. Okay? Now I should find intersection of this pink line and the circle. Okay? So let's calculate. Y is equal to negative 4 over 3x and this circle. X squared plus y squared is equal to 16. Now, if we replace, it is x squared plus 16 over 9. X squared is equal to 16. 9 plus 16, 25 over 9x squared is equal to 16. If you take a square root, as you can see, x here is positive. So if you take a square root, 5 over 3 times x is 4. So x is what? Is 12 over 5. Y is what? Y is negative. Okay, and by this formula you can calculate negative 4 over 3 times x, which is 12 over 5. 3, this one 4, which is negative 16 over 5. So we found xy of this point. Now we want to find 3x minus 4y, maximum of this, and also we should multiply by 27. So answer will be what? 27 times 3x, which will be 3 times 12 over 5, minus 4y, minus 4 times this one, negative 16 over 5. And we want to calculate this. It will be what? 27 over 5, 3 times 12, 36, 4 times 16, 64, which will be what? 100. And if we divide both numerator and denominator by 2, by 5, it will be 20. So it will be 54, 540. Let me tell you two, so the answer is this. Let me tell you two similar problems that one of them is so much similar to this. It is for an exam in Canada, and one other problem similar to this from AIME. I solved that before this exam. It was related to drawing the graph. So how many homeworks did we have? 9 homeworks. So homework 10, problem of AIME. You can solve this problem with similar idea 2021 AIME 1 as homework 10. You can also solve this problem as homework 11 AHSMC. Problem for this problem again can be solved with similar idea. Homework 10 and 11. These problems were related to this part from this part. Now let me tell you a problem that we had in AMC also. That problem was harder than this problem of AIME. In that problem, we should maximize imaginary parts. So let me tell you the problem is what? Homework 12. Again, in this problem of AMC 12, last AMC 12A 2020. You should find maximum of imaginary part. In the problem of AIME, we should find the maximum of real part, here imaginary part, and as I said, this problem is much harder than AIME problem. Okay. And here I told you this idea. Okay, let's try problem 8. Problem 8. 8 circles of a radius 34 can be placed tangent to BC at to side BC of triangle ABC so that the circles are sequentially tangent to each other, with the first circle being tangent to AB and the last circle being tangent to AC as shown. And so it says similarly 2024 circles of radius 1 can be placed tangent to, again like this, tangent to BC in the same manner. The inradius of triangle ABC can be expressed as m over n, where m and n are relatively prime positive integers. Find m plus n. In this problem, we should use something that was similar to one problem of AMC. We had a hexagon. We should draw perpendiculars and calculate, for example, distance from B to C. Okay? Calculate BC in 2 ways. So let me tell you it will be which idea. Here I told you the things, idea 11. Before exam in my videos, I said this idea and solved some AMC problems. Sometimes, for example, you should use double Pythagorean theorem by drawing perpendiculars. Okay. So, I will explain. Here we have how many circles? Let's write 1, 2 to 8. But let's define n as 8 and the radius is r. Okay, and I want to find the formula in terms of n and r, then we can use for 34, radius 34 and 8 circles, and 24 circles of radius 1. Okay, so let's consider this part. Okay, and let's consider, so as you can see, these lengths are equal to this part, and this length, green lengths. Let me maximize it. Okay. So we want to calculate BC in 2 ways. So one part is you say, okay, BC is A, and it is equal to what? We have n circles. If you consider 2 to n minus 1, there are n minus 2 circles, okay? And these n minus 2 circles, each of them we have what? 2r. For them we have 2r. And for this one we have r, for this one we have r. So it is r, it is 2r, 2r, n minus 2, 2r, and 2r's. So plus r plus. Now we've calculated this part. So for calculating this part and this part, let's see what can we do. Let's maximize. Okay, I want to calculate this part. So if we draw C to this center, this one is R, this angle is C over 2. Why it is C over 2? Let me explain this part for you. If we draw also this one, we can say it is R. So this is equal to this one. It is perpendicular to this, perpendicular. These two triangles are congruent. By what criteria? We know also this length is equal to this length. By what criteria? Two sides and angle between 90 degrees. Okay? And because these two triangles are congruent, these two angles are equal, so C over 2. Now, I want to find x. X is what? Let's write tan C over 2. Tan C over 2 is opposite over adjacent, is R over X. So X is what? Is R over tan C over 2. Okay, so now we can say what? By this part, we know it is X, and this one is what similarly, let me write plus. This one is R over tan C over 2. Similarly, if you want to calculate this part, it will be what? R over tan B over 2. Okay? So we found BC like this. Now we want to replace here by this formula if we simplify. N minus 2 here, 2r. If we factor from 2r, it will be n minus 2 plus 1, n minus 1 times 2r plus r times 1 over tan C over 2 plus 1 over tan B over 2. Now, for Inradius, we have what? For Inradius, R, we know the radius of Inradius, and N is what? N is 1. So we can say A is N is 1 times 2R0 is equal to R 1 over tan C over 2 plus 1 over tan B over 2. Okay. Now the problem says what? Inradius means what? We have only one circle. Okay. So N is 1. And radius, we call it radius of Inradius R, or R1, let's consider, because we have R here and we want to replace. Let's consider it is what? It is R1. Now let's consider rest. Okay. So 34. Here N is 8, R is 34. So let's replace. N is 8, R is 34. So A is equal to N is 8, so 7 times 2R, 14R, plus R times 1 over tan C over 2, plus 1 over tan B over 2. Okay. And for next part, N 2024, radius is 1. So N is 2024, and radius is 1. So if we replace A or BC is equal to N minus 1, so it will be 2023. 2024 minus 1, 2023 times 2, 40, 46 R, and R is 1 here. Sorry, here R is what? In this case, R is 34. So let's replace. R is 34. So it will be 34 here, and 14 times 34 plus what r, which is 1 over tan c over 2 plus 1 over tan b over 2, and we want to find r1 is what? Okay, for this part, as you can see, if we subtract these two equations, a will be cancelled and we can calculate this part, okay? So let's call this part, for example, w. So by subtracting these two parts, we can find w, and then when we replace, we can find a. If we find a and w, we can find r1, okay? So if we subtract, or we can say they are both of them are equal to a, so 14 times 34 plus 34w is equal to 46 plus here again w. So if we subtract w from both sides, or take w to left hand side, these to right hand side, it will be what? 33w is equal to 46 minus 14 times 34. So for calculating this part here, is it multiple of 7? Yes, because it is 2 times 2023. And 2023 is a special number. You should memorize factorization of 2023, 2024. 2023, 7 times 17 is squared, minus 14, 2 times 7, 34, 2 times 17. So if we factor, it will be 2 times 7 times 17. And it will be what? 17, 2 times 7 times 17, minus 2. Okay, so it will be what? It will be 15. 15 times 2, 30. 7 times 17, 7 times. So if we write like this, okay, so let's multiply. 15 times 2, 30, 7 times 17. 7 times 7, 49. We have 4. 7 times 1, 7 plus 4, 11. And if you multiply 3 times 9, 27. We have 2. 3 times 1, 3 plus 2, 5. 3 times 1, 3. So it will be this. Now we can find a is what? A is 46 plus w. W is what? This one. Before that, we can also, let's consider this. If we simplify by 3, so I forgot, let's simplify this by 3. So until here, that's enough. So we can say what? W is this one by 33. It is not multiple of 11, but multiple of 3. So if we divide by 3, it will be 10 times this, 1190 over 11. So it will be what? 1190 over 11. Okay? So it will be this. Now, if you want to find R1, A is 46 plus 1190 over 11 equals R1 times W. W is what? 1190 over 11. Now we can multiply both sides by 11. Okay, so it will be 11 times 46, which is 2 times 2023, which is 7 times 17 squared, plus this number, this one was what? 7 times 17 times 10 is equal to R1 times 7 times 17 times 10. So let's simplify as much as we can. 7, 7, 7, 17, 17, 17. And for 10, 2, 5, 2, 5, and 2. So it will be what? 11 times 17, which is 187. Okay? Plus 5 is equal to 5R1. So 187 plus 5 is what? 192. 192, and then we can conclude R1 is 192 over 5. Okay, but the answer wants the problem wants what? Some of them. It says okay, it is in the simplest form. M over n, m plus n is what? So answer, which is m plus n, is equal to 192 plus 5, which is 197. Okay, so if you had any question, you can send message to my WhatsApp number Let me tell you some problems similar to this. Homework 12, homework 13. Okay, homework 13 is this one. It is from AMC 10A 2023. For this one, you should use similar approach. And I did same approach here. And you can solve the problem with same approach. And in my video that I released full solutions of AMC on, it is 10A 2023. I released full solutions of AMC 10A 2023, and in my video I explained how we can draw perpendicular and solve this problem. Let me tell you some other homeworks. So it was homework 13 related to, for example, Inradius and something like that. So it was homework 13. Homework 14, prove that R is equal to area of ABC over semi-perimeter. Homework 15, prove that RA is x radius of A. If you don't know there are what, feel free to send message to my WhatsApp number in the description. Homework 16. Prove that area of ABC is equal to R times RA times RB times RC. Homework 17. Prove that 1 over R, you should prove these things. Y it is equal to 1 over RA plus 1 over RB plus 1 over RC, and also it is equal to Y1 over HA plus 1 over HB plus 1 over HC. Prove these relationships related to Inradius and X-radius. So 17 homework, drawing perpendiculars. Again, for these parts, for this one, you should use same idea, drawing perpendiculars. And okay, we solved this problem 8. Problem 9, it says let ABCD be a rhombus whose vertices all line on the hyperbola. This one, let me write x squared over 20 minus y squared over 24 is equal to 1. And are in that order. ABCD, if its diagonals intersect at the origin, find the largest number less than BD squared for all rhombuses ABC. Okay, so if we consider a rhombus, we can say, okay, we have something like, for example, this one, let's consider AD. This one, which is AD again. And as you can see, okay, so the angles are what? Let me do something. Here, it is AD 30. So this one, again, 80. Okay? And now, if you want to do same thing, it is 30, it is 60, so this one should be 60 again. This, and this. Okay. 80. And this one. Now we have this. It says what? It says, for example, it is A, B, C, D, and this. We can prove easily that in rhombus, because all sides are equal, we can say what this is equal to this one, this one, this one. B and D lies on perpendicular bisector of AC, A and C lies on perpendicular bisector of BD. And we should select, for example, BD, and this one is what? Origin. Okay? So, if you find a point like this and connect, you can say by similarity, when you connect to O, this one is equal to this one. Okay, and we can say these angles are equal, they are similar, so this length always is equal to this length when you connect one point. But here, what's the problem? Maybe if you draw perpendicular, it doesn't intersect this part. Okay, so we should understand that, for example, if it is AC, BD should intersect this one. So under what condition it intersects? For each hyperbola, we can draw two lines, okay, like this. We can say oblique asymptotes, that this hyperbola approaches these two lines. I want to find equation of these two lines. So these two lines in infinity, they are for large x's, for example, and y's. Hyperbola approaches these lines. So how can we find these two lines? We can say if x and y are so much large, we can say, okay, x squared over 20 minus y squared over 24, we can ignore 1 because 1 is so much less than x and y. 0. So x squared over 20, or let's write y squared. Y squared over 24 is equal to x squared over 20. Okay? And then if we multiply by 4, it will be 6, it will be 5. So y squared is equal to 6 over 5 if we multiply by 6 over 5 times x squared. And then if you take square root, y will be plus minus square root of 6 over 5x. Okay, so this line is y over square root of 6 over 5 times x. This line is y is equal to negative square root of 6 over 5x. Okay, and they are not necessarily, we can say they are not perpendicular, because if you multiply these two things, the product should be negative 1. But we can understand that AC and BD, when we draw both of them, should be between these two parts, their slope. Okay, so for example, let's consider, you can consider this part BD. Okay, for example, BD, or that part AC, it's not important. Suppose the slope is this one, is y is equal to sx. Okay, so if BD is equal to y sx, because it passes through origin, we can say sx. We don't have any plus something. AC will be what y is equal to. The product should be negative 1 because they are perpendicular to each other. Negative 1 over s times x. Okay, the product should be negative 1. Now, we know both of them should be between root 6 over 5 and negative root 6 over 5. So s and negative 1 over s, both of them should be between negative square root of 6 over 5 and less than square root of 6 over 5. So we can say what? When something is between these two things, we can say, okay, absolute value of s and absolute value of negative 1 over s is absolute value of 1 over s. It's less than square root of 6 over 5. Okay, now we want to find intersection. We know we want to find length of BD is what in terms of s. So we should find, for example, point B and D. So we say we should find intersection of y is equal to sx and this hyperbola, which is x squared over 20 minus this equation, minus y squared over 24 is equal to 1. So if you find this intersection, the intersections of these two things, one of them is B, one of them is D. Okay, so let's replace. We replace y with sx, so x squared over 20 minus s squared x squared over 24 is equal to 1. Okay? And now, one important thing. We want to find what? We want to find, it says, find the BD squared. Okay? And then we want to find largest number less than BD squared always. So we should find minimum of BD squared and see, okay. The floor of that is what? What's the largest number less than that? Because when it is less than largest number less than all of them, we should find minimum of BD squared is what? First. BD squared is what? This point is sx. Coordinates of B is what? X and sx here. Okay? So because it is x and sx, this one is what? BD is 2BO. BO is what? Square root of distance of origin and this point B. It is x squared plus sx squared. Okay, so we should find this part and the minimum of that is what? And under what condition? We know that they satisfies this one, this one, this one. Okay, so if we calculate, we can see what? We can see, okay, x squared is what? X squared times 1 over 20 minus s squared over 24 is 1. And then we can multiply. I want to calculate x squared in terms of s squared and replace here. Okay? So let's multiply by, I want to get rid of denominators. So 20, here 24 has 360, 120. If we multiply both sides by 120, it will be what? X squared times 126, and this one 5, minus 5s squared is equal to 120. And then we can say what? We can say x squared is equal to 120 over 6 minus 5s squared. And now, BD is what? BD squared, the problem says BD squared. We can say 4 times x squared plus sx squared. So it will be what? It will be 4x squared times 1 plus s squared. And x squared is what? Is this one. So it will be 4 times 120, which is 480, over 6 minus 5s squared times 1 plus s squared. So we want to find what? We want to find minimum of this. Okay. There are lots of ways, but here, let's first simplify this. Here we know, because we have s squared, we know s squared is less than 6 over 5 if we raise to the power of 2, because they are positive. 1 over s squared is less than 6 over 5, so if we apply this, s squared will be greater than 5 over 6. Now we want to use this and solve this. There are lots of ways for solving this part. Coefficient is not important, so 480 times s squared plus 1 over negative 5s squared plus 6. One way you can use derivatives, or let me tell you one other way, you can divide. How you can divide? S squared plus 1 by long division, but because the degrees are equal in one step, we can reach the division. 5s squared plus 6. You say negative 1 over 5, it will be what? It will be s squared minus 6 over 5. And the remainder is what? 11 over 5. So, it will be what? We can conclude. BD squared is 480 times negative 1 over 5, negative 5s squared plus 6, plus 11 over 5 over negative 5s squared plus 6. And if we divide, it will be 480. This divided by this is negative 1 over 5 plus 11 over 5 times 1 over negative 5s squared plus 6. So we should do what? Because we want to, this one is constant, all of them constant except this. We should find the minimum of this part. And 6 minus 5s squared is positive. Why? Let me tell you, because of this part. Let me copy here. If we consider this part, we can say, okay, if we multiply by 5, 5s squared is less than 6. So if we take these to right hand side, 6 minus 5s squared, absolute value of s squared is s squared, so we can get rid of that. It's positive. So I want to find minimum of this, so I should find maximum of what? Maximum of negative 5s squared plus 6. Because I want to find maximum of this, so this one is constant, so it is equivalent to find maximum of negative 5s squared. Because it's negative 5, it is equivalent to find minimum of s squared. Minimum of s squared is what? 5 over 6. Okay? We know that s squared can be so much near to this number, but cannot be equal exactly to this number. So BD squared is always strictly greater than when we replace s squared with 5 over 6. 480. Negative 1 over 5, I want to write this. Instead of s squared, I want to write 5 over 6. plus 11 over 5 times 1 over negative 5 s squared 5 over 6 plus 6. And BD squared can be so much nearer to this, but always greater than this. So, if we calculate, it will be what? It will be 480 times negative 1 over 5 plus 11 over 5 times. Here, it will be what? If we use common denominator in the denominator, it will be negative 25 plus 36, which is 11 over 6. Okay? So, this 11 can be cancelled with this 11. And it will be what? 480 negative 1 over 5 plus 6 over 5. It will be 5 over 5, which is 1, 480. So 400 BD squared can be so much nearer to this, but always greater than 480. Problem says what? Let me write. BD squared is always greater than what? 480. And so much nearer to this. It says, find the largest number less than BD squared for all rhombuses. So answer will be what? 480. Okay, so let me consider the ideas that we've considered here. We considered 12 ideas so far. 13 was to find these two lines, equation of these two lines. Idea 14, let me see here. We can say what? Idea 14 for solving these types of problem, one-way derivatives, one-way long division. You can apply this and resolve this problem. Okay, you can solve this problem of AMC 10b. Again, here we have hyperbola, and it says the vertex of this hyperbola is centroid of a triangle. It's similar to this one. Combination of geometry and hyperbola. In problem of AIME, we had rhombus and hyperbola. Here we have a triangle, centroid, and hyperbola. And you can solve this. We have also some problems in AIME that related to hyperbola, but this problem was a bit harder. Okay, it was homework 18. For next homework, you can try this problem as homework 19. This problem is easier than this problem of AMC 10b, and as you can see, it's problem 2. Let me tell you a harder problem from AIME, homework number 20. You can try this problem as homework 20, AIME 1988, problem 14. Okay, so we solved this problem 9, and I've left 3 homeworks. Problem 10, let ABC be a triangle inscribed in circle omega. So let's consider this one a circle, and it says AB is 5, BC is 9, AC is 10, something like this. And let's consider this one AB and C. Let the tangent to omega at B and C intersect at point P. So if we draw 2 tangent lines, then this one is P. It says let AP intersect omega at D. This omega. So if we draw AP, it intersects omega at D, and then it says find AD if AB is 5, means C is 5, BC or A is 9, and AC or B is 10. Okay, we can say AP is Symmedian. Means what? It's a famous line. Means when you draw this part, AM, these two lines are reflection with respect to angle bisector. Means if it is alpha, this angle is also alpha. Let's prove this part first together, and before proving that, I should tell the ratio lemma is what, and Ceva's theorem. So how many ideas have I told you so far? Idea 13, idea 14. Okay. Idea 15. Ratio lemma is what? It's so much helpful, ratio lemma. It means if we draw something like that, it is ABC. Suppose that we draw an arbitrary line, for example, AK. If it is 1, 2, sine A1 over sine A2 is BK over KC times sine B over sine C. You can prove it by using two sine laws in ABK and AKC easily. Or you can say BK over KC times B over C. So the proof, you can do it as homework because it's not hard at all, as homework 21. Now, let me tell you Ceva's theorem is what. You can use it without proof, but if you search proof in Google, there are lots of proofs. Or if you couldn't find any good proof, feel free to send message to my WhatsApp number. For Ceva's theorem, we can say what? We can say that, for example, we have a triangle ABC and we have three lines like this. This one, this one, this one. So these lines are what? Here, A, B, C. For example, D, E, F. You can say A, D, B, E, C, F are concurrent if and only if A1, A2, C1, C2, B1, B2, like this. Okay, 1, 2, then you are on this side, you go here. Okay, C1, C2, you are on this side. 1, 2. So, if and only if sine A1 over sine A2 times sine C1 over sine C2 times sine B1 over sine B2 is 1. We consider this as clockwise, okay? You should consider one direction and write all of them like this. Sometimes all three lines are not inside the triangle. For example, two of them outside or three of them outside. In this problem, we need this structure. So we can say what? It is A, it is B, it is C. And you say, okay, again, these three lines are concurrent. Sine A1, A2, again, look like this. You are on this side. C1 will be this one. C2 will be this one. You are on this side. B1, B2, okay? And let me tell you what you can do. So now we want to use these things to prove that why these two things are off. Okay? If we use ratio lemma, so I told you these two things, ratio lemma for AM in triangle ABC and AM. It will be what? It will be sine this one A1 over A2. Okay? Sine A1 over A2 is equal to BM over CM, which is 1 times sine B over sine C. BM CM will be cancelled, or you can say sine B over sine C or B over C. Now, if we use Ceva's theorem in triangle ABC for AP, and here I said they are concurrent if and only if. So, for AP, BP, CP, we have what? In this case, we can say A3, A4, then C1, C2, B1, B2. So we can say sine A3 over sine A4 times sine C1 sine C2 times sine B1 sine B2 is 1. Okay. Now we know that this, because it is A, this arc is 2A, so B1 is A, C2 is A, C1, this one is what? A, because it is tangent chord angle. You should know tangent chord angle, inscribed angle, central angle. It is, there are the basic things for angle chasing. If you don't know that, you can send message to my WhatsApp number. For C1, this one is A, this one is C, sine A plus C. We know sine 180 minus alpha, basic thing, idea 17. Sine 180 minus alpha is equal to sine alpha. So because we know A plus B plus C is 180, so this one is A, this one is C. A plus C is equal to sine B. So sine C1 is B. B2 is what? Is A plus B, which is C, because the sum with C is 180. And now you can cancel what? You can cancel this part and this part. So sine A3 over sine A4 is equal to sine C over sine B. Or you can say sine A4 over sine A3, reciprocal of that, is equal to sine B over sine C, which is B over C. As you can see this, we will say, okay, sine A1, A2 is equal to sine A4, A3. They are equal, B over C, and we want to say, okay, so A3 is equal to A2 because some of them is A. Here you can use this, that sine A3 over A4 is equal to A1. A4 over A3 is equal to A1 over A2 to say, okay, they are equal, so A2 or alpha, we can say this alpha equals A3 alpha. But if you want to know a rigorous proof, it is useful to learn how. We don't want to solve only this problem because there are some easier ways to prove this problem. We want to see how we can work with ratio lemma, because for example in USUMMA also useful. In USUMMA 2023 I used something like this in the problem. So let's see how can we prove from this one equals this one, A1 is equal to A4, A2 is equal to A3. So we know sine A1 over sine A2. Let me write. We have this. So consider, for example, let's consider A2 equals alpha and A3 equals beta. We want to prove why alpha is equal to beta. Okay. So here A1 is what? We can say sine A minus alpha over sine alpha is equal to sine A minus beta over sine beta. If we cross multiply, we can conclude sine A minus alpha times sine beta is equal to sine alpha sine A minus beta. Okay? And we have an important formula that sine A times sine B is 1/2 cos A minus B minus cos A plus B. So in this part we can say 1/2 cos A minus alpha minus beta minus cos A minus alpha plus beta is equal to 1/2 cos alpha minus this or this minus this, because we know again it will be which idea? Idea 17, idea 18. We know cos negative A is equal to cos A. So it's not important to write this minus this or this minus this. I write A minus beta minus alpha minus cos of some of them, A minus beta plus alpha. We can multiply both sides by 2. We can cancel this part and this part. They are equal. So, and we can multiply by -1. So cos A minus alpha plus beta is equal to cos A minus beta plus alpha. Now, because we know A alpha is less than A, So both of them are greater than 0, okay? And we know, for example, a minus alpha plus beta, and both of them, a minus beta plus alpha, they are positive. And beta minus alpha is at most a, so it is less than 2a. Okay, and 2a is less than 360 because a is less than 180. Now, if you consider unit circle, considering unit circle again can be useful, so it will be ID and 19. If we consider unit circle, we want to see what happens when cos of them are equal, cos of two angles. So cos is related to this one. It happens when we have something like this because they are positive, or something like this. Okay, then their causes are equal. In both of them, we can say their sum is equal to 360. So we have two options. A minus alpha plus beta is equal to a minus beta plus alpha, or a minus alpha plus beta plus a minus beta plus alpha, because if, for example, it is x1, this angle is 360 minus x1. So if it is x2, it will be 360 minus x2. Why? Because this one is equal to this one, and this one is equal to this. So sum of them is equal to 360. In this case, you can cancel a. We can conclude 2 beta is equal to 2 alpha, and beta is equal to alpha. It was the thing that we wanted. In this case, you can cancel this. So 2a is equal to 360. So a is equal to 180. A is an angle of the triangle, so contradiction. It's less than 180, so alpha is equal to beta. So we worked on trigonometric things, all these things, but we don't need to prove all these things. If you know only this Symmedian, you can use this because it is AIME, not full solution exam. So let's copy this figure. Let's erase the things that we don't want. Okay, so this one. Now, we have an important formula, idea 20, and for you, sum of 2023, I proved this. It is what? AI times AIA is equal to BC. We want to use exactly similar proof by two similar triangles. Here we can say two similar triangles. They are what? So, if we connect this to this one, this angle is what? This arc is 2C because it is C. So this angle is also C. It is alpha. So by two angles, we can say which two triangles are similar. Triangle ABD, similar to triangle AMC. Okay. And then, in triangle ABD, let's consider this one C, this length. C over C corresponds to what in this one? AM. It is equal to what? AD, we want to find AD. AD opposite to this angle. Opposite to this angle is B. So we can conclude AM times AD is BC, like AI times AIA, BC. With similar proof, you should prove again that in this part you should use two similar triangles. In the video that I released around 1 year ago for you summer 2023, I explained this one completely for, I think it was problem 6. Now here, AM is median. We know B and C are what? The problem says B is 10, C is 5, so it's 50. 10 times 5, 50. We want to find AM. We have a formula, MA squared, idea 21. We can use the Stuart's theorem, but also it's good to memorize this formula. With the Stuart's theorem, you can reach this. B squared over 2 plus C squared over 2 minus A squared over 4. So it will be what? B squared is 10 squared over 2 plus C squared over 2, 5 squared over 2 minus A squared over 4, 9 squared over 4. So it will be what? It will be 100 over 2 times this times plus this plus this. Okay, so 100 over 2 is what? Is 50. 25 over 2, so let's use common denominator. So let's use common denominator for all of them. For 100, it will be 200. It's 25 times 2, 50 minus 81. So 250 minus 81. So 250 minus 81, 70 minus 1, 169 over 4. So if we take square root, MA is what? 13 over 2. So memorize this formula, it's important. There are, as I said, around 100, around 40, 50 important formulas in geometry that you should memorize these formulas, okay? So memorize this one and also memorize this one. MA is 13 over 2. So AD is what? AD is 50 over AM, or we can call it MA. So it will be 50 times 2 over 13. So it will be what? It will be 100 over 13. The problem wants what? It says, okay, find AD. We found AD. And then it says, okay. And I think the problem here, we don't have the problem. It's M over N. In the simplest form like this, the answer is M plus N. Okay, so AD is this if you want to write M plus N, because the answers should be integers. It's 100 plus 13, which is 113. You can try this problem as homework 22 related to Symmedian, and try this one. And if you had any question about this problem or other problems, as I said, you can send message to my WhatsApp number. Problem 11. It says each vertex of a regular octagon is independently colored either red or blue with equal probability. The probability that the octagon can then be rotated so that all of the blue vertices move to positions where there had been red vertices is M over N, where M and N are relatively prime positive integers. Find M plus N. So here we should use casework. So let's see, it will be which idea? Idea 2021. Idea 22. For this problem, as I said before the exam, casework always useful. Casework. Casework on what? You should consider what property and split the problem into smaller cases with respect to that property. Here we can consider number of reds. It can be what to what? Because it says rotated so that all the blue vertices move to positions where there had been red vertices. Okay, blue on red. So can we have, for example, 8 reds? No, because if we rotate, we need 8 blues also. So it's not possible. Can we have, for example, 5 reds? No, because you have how many blues? 3 blues. And if you rotate, you can cover at most 3 reds with 3 blues. So 2 reds are left always. So we can conclude number of reds should be always less than or equal number of blues. So because we have 8 vertices, number of vertices can be at most what? 4. So we should consider 0, 1, 2, 3, and 4. Okay, so if we have 0 red, what's the probability? It's always possible the condition of the problem can be satisfied. So how many cases are there? One case. So 1 over. What's the total number of cases? 2 to the 8. So the probability here is 1 over 2 to the 8. Okay. Now, what about this one? If you have 1 red. If you have 1 red, always it's possible because you have 7 blues. Okay, so let me see. If you have 1 red, you have how many blues? 7 blues, and you can rotate. If you rotate one, for example, 1 unit clockwise, then this blue goes here, and the problem will be satisfied. So if you have 1 red, always it will be okay. So how many good cases are there here? 8. All of them are good, because for red we have 8 cases. This one is red, or this one is red. We have 8 vertices, so 8 good cases over 2 to the 8. Now, if we have 2 reds, we want to see is it always okay or not. So 2 reds can be adjacent or without loss of generality. Suppose for example 1 red is this, or the distance is 2, or the distance is what? Let me write it here. Or the distance is 3, or the distance is 4. Okay. Now other vertices are blue. For each of them, I will tell you you should rotate how many units, for example, in what direction. So when here you can say 2 units clockwise. For these things, for all of them, if you shift 1 unit, rotate 1 unit clockwise, it will be okay because each of them has one, because they are not adjacent. Each of them has one blue before that. So when you rotate 1 unit clockwise, this blue goes here, this blue goes here. So for all of them, it will be good. So if we don't have adjacent R's, it can be solved easily by 1 unit clockwise, rotating 1 unit clockwise. So it will be 8, choose 2 over 2 to the 8. This idea can be useful for 3 when we have 3 R's. If they are not adjacent, we know it can be solved. Now, if all 3 of them are adjacent, if only 2 of them are adjacent. Okay, so for this one, for 3, if all of them are adjacent, you should rotate it clockwise. How many units? 1, 2, 3. 3 units. If exactly 2 of them are adjacent, let's see what happens. These 2 are adjacent only. Next one can be here. Or these 2 are adjacent. Next one can be here. If 2 of them are adjacent, next one here. And last one, next one here. Okay. And let me tell you something, because we can rotate clockwise and counterclockwise, we don't need to consider last 2 cases because they are symmetric. Okay, so we need to consider only these 2 cases. For this one, if we move, and let me tell you something, clockwise, counterclockwise, when you rotate 1 unit counterclockwise, it is equivalent to rotate 7 units clockwise. Okay, so we can only focus on clockwise. If you, for this one, 1 unit not possible, 2 units not possible because this R goes here. 3 units is possible or not because 1, 2, 3, this R goes here. Again, 3 units not possible. 4 units, 1, 2, 3, 4. This one will be okay. 1, 2, 3, 4. This blue goes here. This one will be okay. 1, 2, 3, 4. This one will be okay. Okay, so 4 units clockwise. Now for this one. 1 unit, 2 units. 2 units I think is good because this will be good. This will be good. This one goes here. This one goes here. This one goes here. So as you can see, we can see always it is good. So again, 8 choose 3 over 2 to the 8. Now last one, 4. For 4, we should consider again casework. So as you can see, when we consider from 0, 1, it will be harder and harder. When we reach 4 or 3, we will see that this case is harder. You can again split into smaller cases. Okay, you can use casework inside casework. So for 4 adjacency, we can say if we don't have any adjacent R's, we can say if there is no 2 adjacent R's, we can shift 1 unit clockwise if adjacency is similar to this one for 4. 4 adjacent, if we have 3 adjacent R's. If we have 2, 2, or if we have only 2 adjacents. 2, 2 means 2 here, 2 here. So for 4 R, we can rotate 1, 2, 3, 4. 4 units. This one goes here, this, it will be good. If we have only 3 adjacents, okay, let's consider cases. R. Next R cannot be here because it will be like this one. It can be here or let's check. Or it can be here. Okay, so can we shift here 1 unit clockwise? No, because this R goes here. 2 units? No, because this R goes here. Can we shift 3 units? No, because this R goes here. 4 units? 1, 2, 3, 4 goes here. 5 units? 1, 2, 3, 4, 5. This R goes here. 6 units? No. 7, if we shift 7 units, 1, 2, 3, 4, 5, 6, 7, this one goes here. 7 clockwise is equivalent to 1 counterclockwise, and 8 is exactly the same. So this part is bad. Okay, it is the first case that we found and is bad. Now, what about this one? 1 unit clockwise bad, this one goes here. 2 units clockwise bad. 3 units clockwise bad because this one goes here. And 4 units clockwise, 1, 2, 3, 4, this one. 5 units clockwise means 3 units counterclockwise. So this one, it's not good. 6 means 2 units counterclockwise, this one, this one, this one. And this one will be bad again. 7 units clockwise, 1 unit counterclockwise. This one bad. So again, this case is bad. So now let's consider 2 2's. So let's write them here. 2 2's. Means we have, for example, these two adjacents here, these two adjacents here. Or we can say our adjacents are these two and this one. Not good. Not this one, this one. Okay. All other cases are similar. For this one, 1 clockwise is not good. 2 is good or not? Yes, it seems. Oh, no. 2 goes here. It's not good. 3, this one goes here. Not good. 4, this one goes here. Not good. What about 5? 5 means 3 counterclockwise. So 1, 2, 3. Again, bad. 6 means 2. This one goes here. 7 is bad. This one goes here. So this case again is bad. What about this one? For this one, it's easy. 2 unit clockwise. Okay, this goes here. These two blues goes here. So this one is good. This one is good. Now only one case is left. And only 2 adjacent R's. So this one, we cannot select these 2 things. So we can select here. 2 R's that are not adjacent. So it will be this one, these 2 cases are similar. So we should consider one of them or these 2. So it will be like what? Let me consider these 2 and these. Okay, how many units? Let's check this one. 1 unit is not good because this goes here. 2 units not good. This goes here. 3 units. 1, 2, 3 not good. 4 not good. 5 means 3 counterclockwise, not good. 6, 2 counterclockwise, not good. 7, 1 counterclockwise, not good. So again, this case is bad. What about this one? You can move these 2 things here. 1, 2, 3, 4. So if we move 4 units clockwise, this goes here, this blue goes here. And 1, 2, 3, 4, this blue goes here. And this blue goes here. Okay, so this one is good. Now let's see what are our bad cases. Okay. Okay, if we calculate bad cases, we know it is 8 choose 4 minus bad cases. So bad cases for these 3 R's and these are, we can say, okay, this vertex has how many cases? 8. This vertex has how many cases? This one or this one? Both of them are same. So 8 times 2 and because this case also is bad, so when we have 3 adjacent, it is always bad. 8 times 3, 24 for this case. Or 3. For 2 2's like this case is bad. So you can say this vertex is unique if we determine this. These 2 are R's, 2 adjacents here and 2 adjacent here are odd. So how many cases are there? 8 cases. This case we said is not bad. This case was not bad on this case. We have 2 R's, so first we should determine 8, which edge, and then 2 R's like this and 2 R's like this. So it will be 8 times 2, 16. So It will be what? It will be 8 choose 4 minus 8 times 3 minus 24 minus 8 here and minus 16 here. So let's calculate this part. 8 choose 4 is what? Let's write 8 choose 4 minus 24 and 16 is 40 minus 48. 8 choose 4 is 8 times 7 times 6 times 5 over what? Over 4 factorial. 4 times 3 times 2 minus 48. 3 times 2 6, 4 is 2, 2 times 5 10, 70 minus 48. So it will be 22. Okay, now we can write here 22 over 2 to the 8. Now we should calculate each of them. 8 choose 2 is what? 8 choose 2. It's 8 times 7 over 2. You can cancel 4 times 7, 28. So it will be 28 over 2 to the 8. 8 choose 3 is what? You can say 8 times 7 times 6 over 3 factorial, which is 6. 8 times 7, 56. 56 over 2 to the 8. Now, if we add all these numbers, we can say 2 to the 8, which is what? Which is 256. Here it is 1 plus 8, 9. 9 plus 28, 37. 37, 50, 87 plus 6, 93. 93 plus 20 is 113 and plus 2, 115. And as you can see, we cannot simplify because denominator is 2 to the 8, only multiple of 2, and here it is odd. And the problem wants what? It says, okay, when you write it like this as m over n in the simplest form, the answer is m plus n. So 5 plus 6, 11, we have 1. 1 plus 5, 6 plus 1, 7. And 1 plus 2 is 3. So the answer is 371. I've told you how many homeworks so far? 22. Let me write homework 23. You can try this homework as a problem in Casework in Promise 2022. I can say one of the hardest problem in Casework, so much harder than this AIME problem and useful. Homework 24. You can solve SUMAC. It's for Stanford Summer Camp 2022. Problem number 8. Let me show you the problem is what. The problem is this one. Last problem. It is this problem 8. Again, it is hard. And hard means you should consider different caseworks. Okay, means for example in different steps you should split into smaller cases. Problem 8, you should solve part A, it's easier. Part B also is not hard. Part C is harder. But I can say this problem of promise is also much harder than problem of SUMAC. Okay, if you solve these two problems, they are so much helpful for caseworks because in AMC we need that, in AIME we need that, also in some parts of maybe use someone IMO, we should use that. Usually in summer camp problems like Promise, Sumex, Ross, in prestigious summer camps, you should be able to apply casework for hard problems. Problem 12. Define f of x is equal to this. Absolute value of x minus half. G of x is this. Find the number of intersections of the graphs of these two graphs. So, in my previous videos, also in our problems in AIME, in previous problems, I said in some problems you should draw the graph. After solving this problem, also, I will leave some homeworks related to this part. So, here we should draw the graph. Now, here it is x in terms of y. So let's draw this one first. Y is equal to 4gf of sine of 2 pi x. So let's first draw sine of 2 pi x. Okay, so it is what? It is sine of 2 pi x. For x0, it is 0, it will be something like this. Okay, and it will be repeated like this. So here, then, and also in all these problems, you should imagine unit circle, okay? We know when x from 0 to pi over 2, it goes from 0 to 1. When we have pi over 2, when x is 1 over 4. So this one is 1 over 4. In pi, it will be 0. So here, sine is vertical line. So pi over 2 is what? 1 over 2. Then we can write like this. 1 over 2 plus 4, 3 over 4. And then 1. It will be 2 pi. And it will be repeated like this from right and left. Now, next part. It says consider f of this. F takes absolute value first and then subtract 1/2 again absolute value. So let's draw first. We should consider absolute value. So we can say what? We can draw like this. This one, this one, this one. Let me draw this one, this one, this one. Okay. Now we have these values, and it is 1/2 1, and then you can say, okay, 1 plus 1/2 3 over 2 plus 1/2 2, 5 over 2, and so on. It is absolute value. Then in next step, we want to subtract by 2. And in these parts, it is what? It is 1. And in previous part, maximum was 1, minimum was -1. Now in next step, we want to subtract by 2. So let's copy this one. Now let's subtract by 2. If we subtract by 2, we can move the diagram like this. We can say x-axis now is this one. And it will be what? It will be 1/2. This one will be -1. And the one for all these things will be for what? Let me show them again. Because in last part we need them. We don't know and we don't need to find this part. But we know this one is 1 over 4. This part, which related to this point, is 1/2. This maximum, 3 over 4. This minimum is 1. And like this, you can continue. For example, this point is what? 3 over 2. The mid one here is 2. And like this one, here 5 over 2, and so on. Now we should consider absolute value. So if we consider absolute value, we should reflect negative part below x-axis to top of x-axis about x-axis. So if we draw, it will be what? It will be this part, this part, this part, like this one, this one, this one, like this. Okay, so we have these values. And this one is 3 over 4 again. This one was 1/2. This one is what? This one is 1. Again, this point 3 over 2. You can add 1 over 2. This one is 2. And this part was 5 over 2. Okay, and again, maximum of all these things will be 1/2. This one is better to be like this. Okay, so approximate figure is this. Now let's calculate what? It is what? It is f of sine of 2 pi x. Okay. Now we've calculated this, so we should calculate g again. G takes absolute value. We know it is greater than equals 0, so that's okay. Then g, absolute value minus 1 over 4. And then absolute value again. So if we consider minus 1 over 4, let's draw the figure again. We want to see what happens. Minus 1 over 4, it will be like what? Here, it is from 1/2 to this 0. So it will be from 1 over 4 to negative 1 over 4. Again, 1 over 4 to negative 1 over 4. This one, and this part, this part like this. Okay, and we've considered what? From here to here, negative 1 over 4. Now we should take absolute value. Let's see what happens when we take absolute value. And then at the end, we should multiply by 4. If we take absolute value, it will be like this. This one, then, as you can see, for example, it is this one. You say this, but here this part. Okay? Then this one. Then here, it will be like this one. It will be here. This one. And then this part. This one, this one, this one, this part, and then here like this. You can say this part, then this part. Okay? And this one, this, and okay, like this one. Now it is what? Let's erase. If we want to calculate values, let me erase this part, this part, this part. If we consider values, and then we also multiply by 4. So we've reached the thing we wanted. So this one is 1 because it was from 0 to 1 over 4. When you multiply by 4, it will be 1. Now, if we want to calculate the values, it will be what? Here we said 1 over 4 is what? 1 over 4 was related to this max. 1/2 was related to what? When we consider these things, okay, we can say this 1/2 is this one. 3 over 4 is related to this one. Okay, so this, again, we can conclude this part is what? Is related to 1. This part is related to what? This maximum 1 plus 1 over 4 is 5 over 4. This one is 6 over 4 or 3 over 2. So when we consider this again, this one is 1 over 4. This one is 1 over 12, 1 over 2. This part is 3 over 4. This part is 1. This part is 5 over 4. And so on. This one, let me consider this one as 3 over 2. And when we calculate this, let me just correct this one. Green. It will be like this one and this one. Okay. So we've calculated first one. This function. Now let's focus on this one. Again, in this part, we should draw first cosine 3 pi y. But here, let me tell you something. I switch x and y. I first draw this one, and then I switch x and y. Okay, so let's first draw cosine 3 pi x. It will be cosine 3 pi x. So again, if we imagine unit circle, we know cosine first is 1, it's 0 in pi over 2. So what happens in what, for what value of x it is pi over 2, 1 over 6. Okay, so next one is 1 over 6 plus 1 over 6, 1 over 3, 2 over 6. 3 over 6 is 1/2. Then 4 over 6 is 2 over 3. This one is 5 over 6. And if we consider next one, it will be what? Let me tell you. Here, when we reach this one, it is 2 over 3. It is 2 pi. Okay, the period is this one. And you can say, okay, 5 over 6 plus 1 over 6 is 1. Again, 7 over 6 and so on. Now we've calculated this part. So in next part, we should do what? We should calculate f of that. In this case again. So let me make sure this part. F of that, also f of that. Okay. For f, we should calculate first absolute value. Then we should do what? Negative 1/2. Then again, absolute value. So let's calculate first absolute value. So absolute value will be this one, this green chart diagram. And here it is 1 and it is negative 1, so it is 1. So this part, now let's consider negative 1/2. If we consider negative 1/2, so it is absolute value negative 1/2. We have a figure like this. Now we should consider again absolute value. Okay, if you take absolute value, it will be this part. Okay, and maximum is 1/2, range is from 0 to 1/2, and we have these things. Now, so we've applied f of this. Now we should apply g. We should take absolute value first because it is greater than equal 0. We don't need to do that. Minus 1 over 4 and then absolute value, and at the end multiply by 4. So we should first subtract 4. Our function is this now. When we subtract 1 over 4, then the range is from negative 1 over 4 to 1 over 4. Now we should consider absolute value. Okay, so the function will be this, and maximum is what? Is 1, because we multiply by 4 absolute value and multiply by 4. So we have this figure. And we said it is what? Y and x. So we should switch x and y. Now let's compare the two diagrams. Okay, our two diagrams are these, because here we have x and y, so we should say, okay, this one should be y, this one should be x. What about this one? This one is y, this one is x. So if we draw them, this one is something like this. If you want to draw this diagram here, because it is x, it is y, it will be again something like this. Okay, and as you can see, we can consider it is between 0 and 1. So if I draw a line, it is, for example, from 0, if we draw exact figure, from 0 to 1. So here we can consider it will be from 0, for example, to 1. And this thing also is from 0 to 1. So we can conclude all our intersections are here. Okay? So now we want to see each line here is from this point to this point. Each of these things is from here to here. Okay? So how many lines are there? So we can consider what? We can consider 0, 1 to 0, 1. I want to see how many lines do we have from this part to this part. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16 lines or curves like this. How many like this? We should calculate this for. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, until this part, 16 and 24. So we can say we have at least how many intersections? 16 times 24, which is, let's calculate this. Is it 384? I calculated this before. So 6 times 4, 24 is 144. 24, as you can see, it is 384. Now, because near 1 and 1, let me tell you the points are what? This point and this point. If we consider near 1 and 1, we have something like this. Something like this, and also something like this. We don't know. The figure is similar to this one, or what? Maybe it will be something like this. Then in this case, we have two intersections. So how can we understand we have two intersections or one intersection? Okay, so let me draw both cases. One case is this. Let me copy, Ctrl C, Ctrl C, Ctrl C, this. Okay, so let me draw this, and the other case is what? The other case is this one. You have like this one and this one. How can we understand what happens? Here, let me tell you one technique to understand we have this case, two intersections or one intersection. We want to use tangent lines at first. Do you agree this one is on top of this one? Okay. Now, we know that we have one intersection here. Under what case we can conclude that we have another intersection? We should see which one is on top of which one. Suppose, for example, this diagram is 1, this diagram is 2. So now here 2, 1. And here we have intersection. This one is 1, this one is 2. So in this case, we know in the beginning here, 1 is on top of 2, okay, in both cases. But in this case, near 1, 1, 2 is on top of 1. So how can we understand which diagram is on top of which diagram? By tangent line. So if we draw tangent line, here we have one tangent for 2. For 1, we have what tangent? We have this one. Okay. So in this case, if we consider, for example, let's consider it is F1, it is F2. It is F1, it is F2. In this case, which of them is greater? Pink one. Pink on F2. F2 prime near 1, 1 is greater than what? F1 prime. Or we can say at 1, 1. Maybe also they are equal, but we should check. In this case, we have this. Now let's again draw pink one on F1 and red one on F2. So which one is greater here? Red one was for F2. F2 prime is less than F1 prime. F1 prime is slope of this pink line. So by finding derivative in 1, 1, we can find which one is on top of the other one near this point. And in this case, we have two intersections, so we should add one. In this case, we don't have any intersection except this one. So let's see. So because of this one, we should find equation of this one, and we should find also equation of this one near 1. So let me erase this one. Okay, so let's try to calculate, for example, these two things. Y is what in terms of x. So for this one, let's calculate first second one. I consider this one yx, and at the end I will switch x and y. Okay, I want to calculate what this part. So let's move backward. Here we multiply this by what? We multiply this by 4 and consider absolute value. So before that, it will be what? It will be this part. It is we subtract 4, and here it will be what? It will be from here to this part, to mid one. Okay, so it is 2 1 over 4. Let me write with this 1 over 4. Y coordinate is 1 over 4 to 1. To 1/2. Now let's keep moving. Here it was what? We took absolute value. So before that also it was what? From 1/2 to this part. Okay, to 1 over 4 again. Now we subtracted negative 1/2. So this one was 1 over 4. This one is 1/2. So if I add 1/2, it will be from here to this part. It will be 1. It will be 3 over 4. And let's consider now if we keep writing, this part is what? Let me write here with red. Is this one from negative 1 to negative 3 over 4. Okay? I consider y coordinates. Now we want to calculate this part will be what? So, first here, it is what? It is equal to cosine 3 pi x. Okay, in these parts. And then we do what? Here, in this part, it will be negative cosine 3 pi x, because here it was below x-axis. We should consider this. In next step, we should subtract 1/2 negative cosine 3 pi x minus 1/2. And then we consider absolute value. But because in this case it's positive, we don't need to consider negative of that. We should consider again this one. Same function. Now after that, we subtract by 4. So negative cosine 3 pi x minus 1 over 2 minus 1 over 4, which is negative cosine 3 pi x minus 3 over 4. Now next step. In next step, here it considers absolute value because it is on top of x-axis. It will be itself. And then we multiply by 4. So it will be what? Negative 4 cosine 3 pi x minus 3 when we multiply by 4. And I said at the end we should do what? We should switch x and y. So x is equal to negative 4 cosine 3 pi y minus 3. It is the first function that we should find. Let me copy this. It is for this function. Now we should find this value. Again, we should do similar thing. Here, we want to calculate what part? We want to calculate these parts. Okay, so you should see in each part it is related to what? It is related to this part. It is to 1. This one, negative 1 over 4. You multiply by 4. This one is 1 over 4. Okay. Now this part is related to what? Here we subtracted negative 1 over 4. For 1, it will be from here to here. Means y coordinate of this is 1/2, because you should add 1 over 4. This one was 1 over 4. This one was 0. If you add 1 over 4, this one will be 1/2. 0 will be 1 over 4. Now let's consider previous one. Here we did what? We considered absolute value. So because if we consider near 1, so it will be what? It will be from here to here. This one is negative 1/2. This one is negative 3 over negative 1 over 4. Okay. Now let's consider previous one. From 1, we subtracted here 1/2. So if we consider it will be from here, we should add 1/2. 1/2 to negative 1/2, 0. 1/2 to 1 over 4 is 1 over 4. So this one is 1 over 4. Now here it will be from this part to negative 1 over 4. Okay, now let's consider. In this case, it is sine 2 pi x, okay, in this part. Now, because it is negative, when we consider absolute value, it will be negative sine 2 pi x, okay? Then we subtract 1/2, so it will be negative sine 2 pi x minus 1/2. Then it considers absolute value. So because it is below x-axis, so we should consider negative of that. It will be sine 2 pi x, negative of this, plus 1/2, okay? Now, we should subtract 1 over 4. So it will be what? Sine 2 pi x plus 1/2 minus 1 over 4, which is 1 over 4. And then we should multiply this part by 4. So it will be 4 sine 2 pi x plus 4 times 1 over 4, 1. So it is our function that we wanted. Okay, so it is this. Now, for this one, we have this. Now we can say f1 is what, f2 is what. F1 is what, f2 is what. Here. F1, as you can see, f2 is the thing that we have here. It is x-axis, y-axis. So f2 is this one from x to y. We don't need to switch. So f2 is what? f2 in f2, y is equal to 4 sine 2 pi x plus 1. In f1, we can say is what? X. And when I said f2 prime, f1 prime, in both of them, we should consider dy dx. So in this one, x is equal to negative 4 cosine 3 pi y minus 3. Okay, now let's calculate f1 prime, f2 prime. f2 prime is what? Dy dx is equal to this one 4 times cosine 2 pi x by chain rule. Derivative, you should take derivative from this part. It will be 2 pi and plus 1 will be 0. So it will be 8 pi cosine 2 pi x. And if you consider in x1, it will be what? Cosine 2 pi. Cosine 2 pi is what? 1. It is 8 pi. Now for f1 prime. At first, I calculate dx over dy, and then I consider reciprocal of that, because x is in terms of y. So it will be what? Negative 4. Cosine will be what? Negative 3. Negative sine 3 pi y times 3 pi, okay? So it will be negative positive 4, 12 pi sine 3 pi y. And we know this point, x and y are 1. So if y is 1, it will be what? Sine 3 pi is what? Sine 3 pi is 0, so it will be 0. So we can conclude what? Dy over dx is 1 over 0, so it goes to infinity. So it will be what? It will be a vertical line. Okay? So which of them is greater? f1 prime is greater than f2 prime, because it goes to infinity, it is vertical line. So f1 prime is greater than f2 prime. So we can conclude it is this case, and we have one more intersection. So answer is 1 plus 384, which is 385. If you had any question about this, I want to tell you similar problem that you should draw diagram. If you had any question about this, as I said before, feel free to send message to my WhatsApp number in the description. This problem, you can do this problem as similar problem as homework. Let's see how many ideas have we worked on in this problem here. In this part, I told you idea 22. So, idea drawing graph, I said, and the things I told you, I can say paying attention to this part, we can say idea 23. Paying attention to derivatives and Okay, we can say these things. Here it was related more to problem solving. Okay, and let's say how many homeworks did we have? Homework 24. So this problem of AIME, you can try this as homework 25. It is AIME problem. It is AIME 1 2021. You can try this problem. It's similar problem as homework. Problem 13. Let P be the least prime number for which there exists a positive integer n such that n to the 4 plus 1 is divisible by p squared. Find the least positive integer m such that m to the 4 plus 1 is divisible by p squared. Let me tell you two problems that you can solve before this problem with similar ideas. Okay, you can try this one as homework 25, homework 26. The ideas are similar. Homework 26, homework 27. Okay, homework 26. This AIME 1 2019 problem. Homework 27. This problem from PMO. Philippine Mathematical Olympiad. You have to use one idea here for solving this problem that you need that idea for this one. I can say this problem is harder than these two problems. And let me move this to this part to have more space. And let me tell you the ideas that we need for this problem. First, you should know order is what. You should know Little Fermat's theorem is what. Idea 23, idea 24. Idea 24 is what? Okay. If I want to tell you order is what, for example, order of A mod n supposes D. GCD of A and n is 1. It means what? It means that it is definition of order. It means that A to the D should be 1 mod n and D is minimum positive integer that satisfies this. For example, let me tell you some example. Order of 2 mod 7 is what? It means that 2 to the D should be 1 mod 7 and D, and we know that GCD of A and N, 2 and 7 is 1. The minimum positive integer. 2 to the 1 is not good, is 2 mod 7. 2 squared is 4 mod 7. 2 cubed is 8. It's good. It's 1 mod 7 and order will be 3. Okay? And let me tell you another thing. For example, order of 3 mod 4. So 3 is negative 1. 3 squared is 1. Okay? Mod 4. So it's 2. Now let me tell you something. As you can see, we have a period. For example, if you can calculate 2 to the d mod 7, it will be what? 2, 4, 1, again 2, 4, 1. So, for which numbers it is what? For multiples of 3. So, when order is 3, if, for example, 2 to the power of something is 1 mod 7, it is multiple of 3, multiple of order. And we can use this to reach a theorem. If, suppose, for example, order of A mod n is D, and obviously GCD of A and n is 1, and D is a positive integer, minimum positive integer, suppose, for example, A to the m is also 1 mod n. So we can conclude D divides m. So try to prove this as homework 26, 27, homework 28. It's not hard at all. Proof of this theorem. Idea 26, you should know Little Fermat's theorem, and general form of that is Euler's theorem. In this problem only, we need Little Fermat's theorem. If you want to know general form is what, in some problems of AIME, we need general form. You should know Euler's torsion function and something like that. If you want to learn all those things, feel free to send a message to my WhatsApp number in the description. It says what? Suppose P is prime and GCD of A and P is 1, or P doesn't divide A, then A to the P minus 1 is congruent to 1 mod P. Okay, now we want to use these things to solve the problem. Okay, let me copy the problem. Okay, first, in number theory problems, usually you should use modular and divisibility, sometimes both of them, sometimes one of them. It says P is the least prime which there exists a positive integer n such that P divides P squared. This one is divisible by P squared, so n to the 4 plus 1. If we change it to modular arithmetic, it will be n to the 4 is what mod P squared? We can say negative 1. Because this one is multiple of P squared, we can say it is also multiple of P, negative 1 mod P. And then we can say what? We can say, okay, if we raise to the power of 2, n to the 8 is 1 mod P. And we know what? We know, let me just tell you something. Homework 27, 28, homework 29. Try to prove also this one. Proof of Little-Fermat's theorem. The idea is useful. And for Euler's theorem also we should use same idea. So, n to the 8 is 1. Now suppose order of. Obviously, n and p GCD of n and p is 1. Why? Because if n is multiple of p, it is not 1, it is 0. Suppose order of n mod p is d. By the theorem I told you, idea 25, we can conclude d divides 8. Okay? So, d is 1, because d is positive integer. 2, 4, 8. I want to prove it can only be 8. Why? Because if d is 1, if d is 1, it means what? By the definition of order. N to the 1 is 1 mod p. So, n to the 4, if we raise to the 4, n to the 4 also is 1 mod p. N to the 4 is negative 1, n to the 4 is 1. So, 1 is negative 1 mod p. So, we can conclude p divides the difference. P divides 2, so p is 2. So, we should first reject p2, then we can say, okay, we can reject these things. If p is 2, what happens? If p is 2. It says p squared 4 divides n to the 4 plus 1. We know n mod 4 is only 0 and 1, so that's a contradiction because n mod 4 is 0 plus 1 and 2. Mod 4. And if we calculate n to the 4, 0, 2 also will be 0, plus minus 1 will be 1 mod 4. So n to the 4 plus 1 is what then? 0 plus 1. 1, 1 plus 1, 2 mod 4. So n to the 4 plus 1 cannot be mod 4 because the remainder should be 0. So that's a contradiction. So here we can conclude p is at least 3 in the beginning of the problem. And we say, okay, p cannot be 2. Exactly. By the same way, we can reject what? Let me cut them. We can reject d2, d3, d2, and d4. Okay? Again, we can say, okay, if d is 2, then if we raise to the power of 2, then it will be 1, and it's not possible for 4 again. If n to the 4 is 1, then here also negative 1, so 1 is congruent to negative 1, and p is 2. So d has to be 8. Now, by Little-Fermat's theorem, we know n to the p minus 1 is 1 mod p. And by the theorem that I told you, idea 25, we can conclude what? We can conclude d divides p minus 1, which 8 divides p minus 1. So, p is 8k plus 1. So, the minimum p that we can find, k1, it doesn't work, 9k to 17, p 17. So, we should check. Is p17 okay or not? Okay, So here it says find minimum m, that m to the 4 plus 1 is divisible by p squared. So because m to the 4 plus 1 is divisible by p squared, we know m to the 4 again is congruent to -1 mod p squared, and we can say m to the 4 is also -1 mod p. So it is not equivalent, that it is, but it is a necessary condition that we have. So here we can say what? M mod 17. I want to see which m's satisfy this. I want to write all cases. It can be 0 plus minus 1 mod 17. And here our p is what? 17. So let's change all of them to 17. We want to see, is 17 good or not? Plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus 6, plus minus 7, plus minus 8. Up to this part, this homework is similar to this problem. From the rest of the problem, this homework is useful. Binomial expansion. And before exam, I released a video and in that video I explained this part, this problem homework 27. And we should use exactly the same idea. Plus 8 minus 8. 17 minus 8 is what? Is 9. So we've considered all cases. Now m to the 4 is what? 0 plus minus 1 to the 4 is 1. 2 to the 4, 16. Negative 2 to the 4 also 16. Negative 1. 3 to the 4. For calculating 3 to the 4, we can say it is what? It is 27 times 3. 27 mod 17 is 10. 10 times 3 is 30. 30 is what? Negative 4. Okay? So it's negative 4. For 4 cubed, for 4 to the 4, it will be 16 squared. It will be negative 1 squared, which will be 1. For 5 to the 4, it will be 25 times 25. It will be 8 times 8. It will be 64. It's negative 4. 6 to the 4 is what? It's 36 times 36. It's 2 times 2, which is 4. 7 to the 4 is what? It's 49 times 49. 51 is multiple of 2, multiple of 17. So negative 2 is 4. 8 to the 4 is what? It's 64 times 64. 64 is negative 4. Negative 4 because 68 is multiple of 17. 4 times 17 is 16. 16 is negative 1. So which numbers are negative 1? Because m to the 4 should be negative 1. This one and this one. So we can conclude what? We can conclude m mod 17 can be plus minus 2 and plus minus 7 mod 17. Now we know m to the 4 should be negative 1 mod 17 squared. Okay? Mod 17 squared. So here we should consider 4 cases. M is 2. Let's see what happens. Mod 17. So it means that M is 17. For example, A plus 2. So m to the 4 here, we should use binomial expansion. Let me write m to the 4 here. Is 17a plus 2 to the 4. So we can say 2 to the 4 plus 4 choose 1 times 2 cubed times 17a plus 4 choose 2 times 2 squared times 17a squared, and so on. And as you can see, if we consider mod 17 squared, from here, because it's 17 squared, 17 cubed, all these things, we can ignore because they are 0. Okay? So it will be what? It will be 16 plus 4 times 8, 32. 32 times 17a, it should be negative 1 mod 17 squared. We should subtract 16 from both sides. If we subtract 16 from both sides, it will be what? Right hand side will be 7, negative 7. So 32 times 17a is congruent to negative 17 mod 17 squared. Now, let me tell you another idea. I told you how many ideas? 26. Idea 27 is what? If AB is congruent to AC, in modular arithmetic, you can do anything you want. Only if you want to divide, you can multiply, add, and subtract. But if you want to divide, you should pay attention to something. Suppose we want to divide by A, so B is congruent to C mod M over GCD of M and A. Okay? Now, we want to use this one. Here I want to divide 17, so it will be 32a is congruent to negative 1 mod 17 squared over GCD of 17 squared and 17, which is 17 over 17 squared over 17 mod 7. Now, 32 is what? Is negative 2. Negative 2a is congruent to negative 1. Then we can conclude what? Mod 7. We can multiply by negative 1, 2a is 1 mod 17. Here you have, we can multiply by 9, or you can say 2a is 1, you can add 17, 18 mod 17, and then you can divide by 2. So a is congruent to 9 mod 17. So a is 17, a prime plus 9. And if we replace, we want to find minimum m in this case. Minimum m, and m should be positive integer, okay? The least prime, find the least positive integer m. So, a should be positive, because if a is negative, it will be, for example, negative 1, negative 8, and then it will be negative. So, a prime can be 0, then a is 9, so minimum n a is negative 17 times 9 plus 2. In this case, it's what? 9 times 17, 9 times 7, 63, 9 times 1 plus 6, 15, 153 plus 2, 155, okay? It is our first case. For each case, we want to find minimum answer, and between those 4 minimum answers, we should find minimum is what? Okay, now let's consider second case. M is negative 2 mod 17. M is negative 2 mod 17. So we can say M is 17b minus 2. So again, we should do same thing. M to the 4 is 17b minus 2 to the 4. So if you consider like this, it will be 2 to the 4 minus 4 choose 1, 2 cubed times 17b is congruent to what? Negative 1. And again, because 2 to the 4 is 16, it's mod 17 squared. So we can subtract 16, so it will be negative 4 times 832 again, times 17b is congruent to what? Negative 17. Mod 17 squared. Again, if we divide both sides by, let's divide by negative 17. So 32b is congruent to 1 mod 17. And 32b is negative 2b. So negative 2b is congruent to 1, and mod 17 17. Let's write mod 17. And then you can say, okay, 2b is congruent if you multiply by negative 1, 2b negative 1, add 17, 16. And b is what? B is 8. If you divide by 2, GCD of 2 and 17 is 1. So then we can conclude it is what? Let me move this to new page. Okay. So b is 8. Now we can say b is 17 b prime plus 8. So if b prime is -1, this one will be negative. If b prime is 0, so b is 8 and you can replace. So minimum m in this case is what? b8, 17 times 8 minus 2. 8 times 7, 56. We have 1, 5. 8 times 1, 8 plus 5, 13. Minus 2, which is 134. So by considering case 1 and 2, case 2 is better. 134 is better than 155. Okay, now let's check case 3. In case 3, m is 7. Case 3, m is 7 mod 17. In this case, let's calculate again. We can say m is 17c plus 7. M to the 4. We can say, I told you how many ideas? 27. Idea 28 was this one. Consider binomial expansion in modular arithmetic. So, m to the 4 is what? Mod 17 squared is again 17c plus 7 to the 4 is congruent to 7 to the 4 plus 4 choose 1 7 cubed times 17c. It should be -1 mod 17 squared. Okay, now 7 to the 4. If we take it to right hand side, let's calculate it is what? We know that it should be multiple of 17. So let's write 4 times 7 cubed times 17c -1 minus 7 to the 4. Mod what? Mod 17 squared. Here, let me tell you something. It's plus minus 8, we said, not 7. So let me correct this part. Plus minus 8. So this one I should correct it. It is 8, it is 8, it is 8, 8 to the 4, 8. And 8 cubed, 8 to the 4. Okay. So m is 8. This one, 8 to the 4, 8 cubed. And this one, okay. 8 cubed, 8 to the 4. 8 to the 4 is what? Is 2 cubed, 2 to the 12. 2 to the 12 is what? 4096. And if we calculate this one, it will be -409 minus 1, 7. And now if we divide it by 17, 4 times 8 cubed, c is congruent to -2 times 17, 34, 69. 4 times 17, 68, 17, 1. So it is what? Mod 17. Now we should find c is what? Mod 17. 4 times 8. So I should consider this one like this. 4 times 8 times 8 times 8. And c -241. -241 minus 17 is what? -24. 1 times 17, 17. We have 7, 71. 68, 71 will be -3. 4 times 8 is 32. 8 times 8 is 64. 32 is what? -2 mod 17. 64 is what? -4. So -2, it's mod 17. -2 times -4 is 8. So 8c is congruent to -3. Now if we add 17, it will be 14. We can divide by 2. 4c is equal to 7. We can add 17 again, 24. Then c is congruent to 6 mod 17. And so the minimum c we can place here is 6. So minimum is m 17 times 6 plus 8. 6 times 7, 42. We have 4. And then 102 plus 8. So in this case, 110. So between case 1 and case 2 and case 3, best answer is 110, okay? Because 110 here, 134, 155. One case is left, m is negative 8 mod 17. Case 4. M is negative 8 mod 17. So we can say M is 17, for example, E minus 8. And then we can say M to the 4 mod 17 squared is 8 to the 4 minus 4, choose 1, or 4 times 8 cubed times 17E is congruent to negative 1 mod 17 squared. Okay, 8 to the 4, when we want to calculate, also for previous part, we could do this. 8 to the 4 is, because it's 17 squared, let's do something first. We can say negative 4 times 8 cubed times 17e is congruent to negative 1 minus 8 to the 4. And we can reach exactly same thing, negative 1, negative 40, 97. Negative 40, 97 mod 17 squared. And if we divide both sides by 17, it will be negative 4 times 8 cubed. E is congruent to what? If we divide by 17, negative 241, which is negative 3. Mod 17. And also we calculated this part, negative 2, negative 1, 8. Here, because it is negative of that, it is negative 8. E is congruent to negative 3. Negative 3 plus 17, 14. We can divide by 2. Negative 4e is 7. Again, if we add 17, 24. We can say e is congruent to, we can divide by negative 4. It will be negative 6, 17, 11. Okay, so if you want to find minimum of this, we should write 11. So it will be minimum is 17 times 11 minus 8. 17, it will be 187 minus 8, which is 170, what? 79. Okay, it is our last answer. So between all these numbers, which number was best? 110. Okay, so it says find the least positive integer, and answer is 110. You can solve these two problems, as I said in the beginning. This one related to order, this one related to, again, binomial expansion. In some problems of AIME, you can apply idea 28 or you can apply other ideas. In this problem, you have to apply idea 28, I think. Or if it has another solution, it's hard to reach that solution. So try these two homeworks to get good at this idea, and we've considered 28 ideas and 27 homeworks so far. Problem 14. Let ABCD be a tetrahedron such that AB is equal to CD is equal to square root of 41 ACBD, or square root of ADBC and AD, or square root of 89. There exists a point I inside a tetrahedron such that the distances from I to each of the faces of the tetrahedron are all equal. It means it is similar to, for a triangle, we have in center. We have this in 3D. This distance can be written in the form m root n over p, where m and n and p are positive integers, m and p are relatively prime, and n is not divisible by the square of any prime. Find m plus n plus p. Okay, first, these three numbers are special numbers. Okay, we should consider this one first. Square root of 41. 41 is something squared plus something squared. 80 is something squared plus something squared. 89 again is something squared plus something squared. And for 41, we can say, okay, 36 plus 5 not good. 25 plus 16 is good. Okay. For 80, for example, 25 plus what? 55 not good. 16. Plus what? You can say 70, 64. 64 plus 16. And if you consider 64 plus 25, it will be 89. Okay. This is good. Why? Because we can consider this tetrahedron in a cuboid. It is what, for example? This one, it is, let me write each of them what squared. 5 squared plus 4 squared. One of them 8 squared plus 4 squared. One of them 8 squared plus 5 squared. So lengths are 4, 5, and 8. So we can draw like this. For example, it is 4, it is 5. This one, it is 8. So we can draw like this. This one, this. Okay. Now we can say, okay, if this one is 4, this one is 5, this one is 8, we can say, okay, 5 squared, for example, plus 4 squared. We can draw this one here. And let me draw complete cuboid. So we can consider this point as origin. We can consider this one, this one, this one, these points, and we should draw this one. Okay, it is our tetrahedron, and these are our points. So 4, 5 is what? It's 41. So we can consider this one A, this one as B, and then we know next one it is 4, 5. 5, 8. 5, 8 is what? Is 89. B what is 89? BC. So this one is this. So as you can see, for example, AC, 4, 8. 4, 8 is 80. AC is root 80. Now, C what is 4 and 5, 41? CD. So this one is D, and it is our ABCD. So it is our tetrahedron. Now we have another thing. Let's work on this one. This R is similar to what? The distance is similar in 2D. It's similar to Inradius. So I should tell you how can we calculate Inradius. Idea 28, idea 29. Then we want to use same thing. We have a formula for Inradius in a triangle. It is equal to area ABC over semi-perimeter. Now let's try to prove this. Try this one first on your own. We have this triangle, and if we connect center to sides, it is A, this one is B, this one is C, this one is R, this one is R, this one is R. We know R is perpendicular to sides, and if we connect I, we call I in center to all three vertices, area of ABC is equal to, let's call this one I, is area of ABI plus area of ACI. There are around 40, 50 important formulas in geometry. One of them this. If you want to learn them, feel free to send message to my WhatsApp number in the description. Now, here we know this side is A, this side is B, this side is C. ABI is what? Is R times C over 2. ACI is R times B over 2, and BCI is R times A over 2. If we factor from R, it will be C plus B plus A over 2, which is what? Semi-perimeter. R times S. And if we divide both sides by S, R is equal to area of ABC over semi-perimeter. Now we want to use similar formula for 3D. So pause the video and at first try to see, can you find similar formula? Here again, we can multiply R if we connect these two vertices. We should calculate volume, okay? And for each of them, it will be R times area. So it will be R times sum of areas over what? Some of the areas of faces over what? Over 3, because volume is this, equal to volume of this figure. Okay? So R is equal to volume over sum of the areas over 3. Here we had over 2, because for area we should divide by 2. For volume we should divide by 3. So our radius is this. So for this part we should calculate volume of this figure tetrahedron and also calculate sum of the areas. So let's first try to calculate area of this figure, volume of this figure. So volume is what? We can say volume of the whole figure is 4 times 5 times 8. Now we should subtract this part. It will be what? 4 times 5 times 8. This area is 5 times 8 over 2, then multiply by 4 over 3. So it will be 4 times 5 times 8 over 6. How many of these things do we have? One here on this corner, one on this corner, one on this corner, and one for this corner. So we should multiply by 4. Okay, and then it will be what? It will be 4 times 5 times 8. 1 minus 4 over 6, or 2 over 3. Or 1/3 of that. So 4 times 5 times 8 over 3. 4 times 5, 20. 8 times 20 is 160 over 3. Okay, now let's calculate areas. Area of each of them. You can see that area of all of them are similar to each other. You can use cross product, or you can use Heron's formula, but a new form of Heron's formula. Idea 29. We should calculate area of one of them and then multiply by 4 for tetrahedron. Idea 29, idea 30. For idea 30, we want to find new form for Heron's formula. Idea 30. New. It was also useful in one problem of AMC. New form of Heron's formula. Then we have a square root. Because if you want to use Heron's formula, each side is a square root of something. So, let's calculate the sides. Sides are what? Root 89, root 41, 80, 89. If we use typical Heron's formula, then we have lots of squares, and it's hard to get rid of them. But let me tell you another 4. By Heron's formula, we know area is equal to square root of s times s minus a times s minus b times s minus c. And we know s is what? S is semi-perimeter. It's a plus b plus c over 2 in a triangle. Now if we raise to the power of 2, abc squared is equal to s times s minus a, s minus b, s minus c. And we can say it is equal to s is a plus b plus c over 2, s minus a is b plus c minus a over 2, and s minus c is a plus c minus b over 2, and s minus c is a plus b minus c over 2. Okay, if we multiply both sides by 16, 16 times area of ABC whole squared is equal to, I want to get rid of denominators, a plus b plus c, b plus c minus a plus c minus b, and b a plus b minus c. Okay. Now we want to use this identity, x minus y times x plus y is equal to what? X squared minus y squared. So, here. If we multiply these two things, it will be b plus c squared minus a squared. If we multiply these two brackets, c minus c negative bb, it will be a squared minus b minus c whole squared. Now, here we can say what? We can say it is equal to b squared plus c squared plus 2bc minus a squared and a squared minus b squared minus c squared plus 2bc. And then it will be what? A negative 2bc only have same sign. So 2bc whole squared minus a squared minus b squared minus c squared. Okay, or we can say b squared plus c squared minus a squared whole squared, which will be what? 4b squared c squared minus b squared plus c squared minus a squared. Now here we know that our sides are these things. We can use this new form of Heron's formula. We know 16 times area squared is what? Times area squared. Let's consider, for example, this one B, this one C, this one A. So it will be 4 times B squared 41, C squared 80, minus B squared is 41, plus C squared 80, minus A squared 89, whole squared. Okay. 80 minus 89 is negative 9. 41 minus 9 is 32. Okay. Now, if we divide both sides by 16, it will be ABC squared. 4 will be cancelled. 41. We should divide 80 by 4. 20 minus, we should divide 32 inside square root by 4. 32 by 4 is 8. 8 squared. So it will be what? It will be 2. 8, 0 minus 8 squared. 64. And let's do something. Here we can say we can factor from 4. It will be what? 41 times 5 minus 64 over 4, 16. This one is what? 5. 5 times 4, 20. 205. So it will be 4 times 15 minus 6, 9. 9 minus 1, 8. 189. So area is what? Is 2 times the square root of 189. Square root of 189. It is multiple of what? Multiple of 9. So you can factor 3. You can take 3 outside. It will be 6. And you can divide by 9. 6 root 21. Now we can solve the problem. Area of ABC is this. Okay, because area of ABC is this, we can say 6 root 21. Let's replace in our formula. 6 root 21 times 4. Because we have 4 faces, all of them have this area. Volume was what? 160 over 3. 160 over 3. Let's simplify as much as we can. 440. And with this one, 320. So it will be what? It will be 20 times 3 root 21. Okay. And now the problem wants what form? The problem says m root n over p. So we should rationalize. We should multiply by root 21 over root 21. So it will be 20 root 21 over 3 times 21. 3 times 21 is 63. And we cannot simplify more. So it says it should have m root n over p, and m plus n plus p is what? M root n over p. So answer is what? Is m plus n plus p. M is what? M is 20. N is what? 21. P is what? 63. 3 plus 1, 4. 6 plus 2, 8 plus 2, 10. So the answer is 104. Okay, let me tell you a homework. How many homeworks did we have? 27. Homework 28. We had similar problem, only the numbers were different in SMO 2022, I think, Singapore Mathematical Olympiad. A is this, B is this, C is this. You can calculate area of this. You can use new forms of Heron's formula, or you can use something like this. You can draw a triangle for this one, the rectangle. And then say, okay, we have something like this, and again, like this problem of, like the problem of AIME, say, okay, what squared plus what squared is 61, and also for 113, and try to calculate these things. So solve it with both ways. So homework 28, solve it with Heron's formula, new form, and as homework 29, solve again this problem with this method, because both of them were useful in this problem of AIME, problem 14. Problem 15. Let B be the set of rectangular boxes with surface area 54 and volume 23. So if we consider the side lengths are ABC, AB plus AC plus BC, 2 times this is 54. The volume is ABC is equal to 23. If we have a cube like this, for example, suppose we have this part, these things, and the sides are cuboid. The sides are A, B, C. The volume is this, and it says let R be the radius of the smallest sphere that can contain each of the rectangular boxes that are elements of B. So we know that for each cuboid, the diameter should be greater than this. This one is what? Square root of A squared plus B squared plus C squared. So 2r should be greater than equal always this length, a squared plus b squared plus c squared, to contain all points of this cuboid. So we can say r is at least a squared plus b squared plus c squared over 4, r squared, because it says r squared. So we should calculate this part, but it says it should contain for all rectangular boxes. So we can say what? We should find maximum of this, because the minimum r, why it says minimum r? Because maybe you can say, okay, r is 10 to the power of, for example, a so much large number. It says minimum that contains all of them. So it means what? For each of them, you should calculate these. For example, r squared in one case should be greater than or equal to 6, in one case greater than or equal to 7. It should satisfy all these conditions for different cuboids. So we should find maximum of this part, and then r squared will be equal to maximum of a squared, b squared, c squared that satisfy these two equations. Okay, so our goal is what? Find maximum of a squared plus b squared plus c squared. And let me tell you something. We know a squared plus b squared plus c squared is what? Is a plus b plus c squared minus 2ab plus ac plus bc. Because we know this part is 54, so maximizing this part is equivalent to maximizing this. Okay, so maximizing a plus b plus c. Now, here we have, I want to tell you, Lagrange multiplier. And I will explain this problem for you, Lagrange multiplier. In SMO, we have lots of problems every year related to Lagrange multiplier. I will explain for you it is what in this problem. So in Lagrange multiplier, you should have one condition and then you should find maximum of something. Because we should have one condition, here how many conditions are there? We have two conditions, ABC 23 and AB plus AC plus BC is 27. How can we change this to one condition? By replacement. From second equation, we can say C is equal to 23 over AB. So if you replace in first one, AB plus AC is what? 23 over, because A times this, A and A will be cancelled, 23 over B. Plus BC, if you multiply B by this, 23 over A. It is equal to what? 27. And it is our condition. And we want to find maximum of what? Maximum of A plus B plus C. So In Lagrange multiplier, it will be which idea? I told you last one, 30. New form of Heron's formula, 31. Lagrange multiplier. So, you should have one condition G, that G is 0. Okay, here, our G is what? AB plus 23 over B. Sorry, A plus, here it was AB, yes, AB, sorry. AB plus 23 over B plus 23 over A minus 27. It is equal to 0. And you should have a function that you want to find, for example, minimum or maximum of that function. Here, our f is what? A plus B plus C. And then you should define a function. L is equal to f minus lambda g. Lambda is what? Lambda is a variable, constant variable, and you will see how can we use this, okay? So, here L is what then? F minus lambda g is equal to A plus B plus C minus lambda AB minus 23 lambda over B minus 23 lambda over A plus 27 lambda. And then we should take derivative from L with respect to only, for example, here we have A equal to 0 and with respect to B equal to 0. So when we write this sign, for example, take derivative with respect to A, we should consider other variables as a constant, okay? So, here, because we should get rid of, we can see, we can replace it with 23 over AB, okay? So, 23 over AB, and here 23 over AB. Now, if we take derivative with respect to A, this one will be 1, B will be 0, because B is like a constant when we take derivative with respect to A by this sign. 23 over B, but when you take derivative, it is a constant coefficient. For 1 over A, it will be negative 1 over A squared minus lambda B. This one will be 0. Again, this one will be negative 23 lambda times negative 1 over A squared. This one is 0. Okay? And the problem is symmetric with respect to A and B. We can find B like this. So we say what? 1 minus 23 A squared B minus lambda B plus 23 lambda over A squared is equal to 0. Okay. Now let's do something. Let's multiply. I want to get rid of denominator. So let's multiply by A squared B. So it will be what? A squared B minus 23 minus lambda times A squared B squared plus 23 lambda B is equal to 0. Now I want to, let's write something. A squared B minus 23 is equal to, let's take these two things that contain lambda to the right hand side. So we can factor from lambda B. It will be A squared B, okay, minus 23. Now, if we consider lambda, if we take derivative from L with respect to B0, then we reach similar thing. We should switch A and B. AB squared minus 23 is equal to lambda A times B squared minus 23. Okay. Now I want to calculate lambda in both equations and say, okay, lambda is equal, so other parts are equal. But we should check this part shouldn't be 0 because we want to calculate lambda. We should divide by the coefficient. So we know B and A are not 0 because they are side lengths of the cuboid. If this part is 0, let's see what happens. Case 1. If A squared B minus 23 is 0, we know C was what? We've calculated C. C was 23 over AB here. I want to say in all cases, two of them will be equal. A is equal to B, or B equals C, or C equals A. By Lagrange multiplier, we can reach this result. So In this case, let's see which two of them are equal, A or B or C. C is 23 over, let me write, C is 23 over AB. By this one, A squared B is 23. So because we need AB here, let's divide by A. AB is 23 over A. So if we divide 23 over, AB is 23 over A. If we cancel, it will be A. So in this case, C is equal to A. So otherwise, if it is not 0, we can calculate lambda. Lambda is equal to A squared B minus 23 over, this part is not 0, B times A squared B minus 23. Now next part for this one. Again, you can say AB squared minus 23 is equal to 0, and similarly, you can reach that C is equal to B in this case. Otherwise, we can calculate also lambda from here. It will be AB squared minus 23 is equal to A times AB squared minus 23. Now, we know both of them are equal to lambda, so they are equal. And because they are equal, we can say what? We can say A squared B minus 23 over B times A squared B minus 23 is equal to what here? AB squared minus 23 over A times AB squared minus 23. Okay? Now, because we know these parts are not 0 here, what about this part? So, A squared B minus 23. So, we can do something. We can see that, okay, when we divide, we can divide this, it is 1 over B. And this one we can divide, it is 1 over A. So, lambda is equal to 1 over A, 1 over B. So, we can say what? 1 over A is equal to 1 over B is equal to lambda. So, from here, we can conclude A is equal to B. So, we can conclude two of them will be equal if we want to find maximum of this function. Okay, now it will be easier to work with. So because let me copy this on this. Okay, so here we can conclude that two of them are equal without loss of generality. Suppose that C is equal to B. Okay, so we can say AB plus, we replace C with B. AB plus B squared is equal to 27, and AB squared is equal to 23. So from here, 2AB plus B squared is equal to 27, and from here, AB squared is 23, and we want to find maximum of what? Maximum of, in general, we want to find maximum of A plus B plus C, or A squared plus B squared plus C squared. And at the end, we should divide it by 4, okay? We want to calculate maximum of A squared plus B squared plus C squared over 4. Our maximum will be what then? Because we should replace C with B. It will be maximum of A squared plus 2B squared over all over 4. Again here, we can use replacement. From which of them? From this one. A is 23 over B squared. And if we replace the first one, and here it is equivalent, we want to see it is what? But it is equivalent to maximize A plus B plus in the beginning of the problem. I said this. And let me tell you something. Lagrange multiplier, idea 31. I wrote this part. Okay. And replacement. Another idea that was so much useful in this problem, replacement. Idea 31. Idea 32. Replacement in all years of AMC and also AIME, it can be useful. So here, let's replace. A is 23 over B squared. 2AB will be what? 2 times 23 over B squared. times b plus b squared is equal to 27. Now, if you cancel, it will be 46 over b plus b squared is equal to 27. Now, let's multiply both sides by b to get rid of denominator, b squared 27b. Now, we can factor b cubed minus 27b plus minus or plus 46 is equal to 0. Now, when the degree is 3, usually 90% of the problem, idea 32, we should use factor theorem. Idea 33. In also AMC 2023, last AMC we had similar problem that you should use factor theorem. You should check for some numbers to see do we have any answer. If you replace 1, it is not 0. If you replace 2, it will be 2 cubed minus 54 plus 46, which will be 8 minus 54 plus 46. 46 plus 8 is 54, it will be 0. So because b2 is one root, so b minus 2 you can factorize. B squared b cubed minus 2b squared plus 2b minus 4b minus 23b plus 46 is equal to 0. So here we can conclude our answers are what? B is 2 from this part. From this part, you should use quadratic formula. B is negative 2 plus minus square root of b squared 4 minus 4ac. So plus 4 times this plus 92 over what? Or let's write like this. 4 times 23. And then over 2a. Now, if you divide both numerator and denominator by 2, negative 1 plus minus square root of 1 plus 23. So it will be negative 1 plus minus square root of 24. B is side length. B should be positive, so we can conclude B should be root 24 minus 1. Now we should see for which of them our function is maximal. For this one, we check this part, a plus b plus c. It's easier to check, and at the end, when we find the good case, we calculate this part, okay? So, b is 2. Let's calculate a, b, c. In this case, b is 2, and we want to see a plus b plus c is maximum, in which case b is 2, c is 2. In this one, it is root 24 minus 1, root 24 minus 1. And a is what? We said a is 23 over b squared. A is 23 over b squared. So in first one, it will be 23 over 4. In this one, it is 23 over b squared, which is root 24 minus 1 squared. Now, in this case, when we add 4 times 2 plus 2, 4. 4 times 4, 16. 16 plus 23, 39 over 4. In this case, the sum is what? 23 over root 24 minus 1 whole squared plus 2 times root 24 minus 1. Okay, let's calculate. We want to see which of them is maximum. This one is obvious. Let's focus on this. 23, if we rationalize, we can say root 24 plus 1 whole squared. And this one will be what? Will be 24 minus 1, 23 squared. So we can cancel this. Also, we have 2 root 24 minus is equal to what? 24 plus 1, 25, plus 2 root 24 over, let's check, 24 plus 1, 25, and 2 root 24 over 23 plus 2 root 24 minus 2. Okay? And if we simplify, it will be what? 23 times 2, 46 plus 2, 48, root 24, 23 times negative 2, negative 46, negative 46 plus 25, which will be what? Minus 21 over 23. Now we should check which of them is greater, 39 over 4 or this value. So let's check 39 over 4 or this value, 48 root 24 minus 21 over 23. Now we cross multiply 39 times 23 4 times 48 root 24 minus 4 times 21, which is minus 84. Because we have a square root, we should take these to left hand side and then square both sides. 39 times 23 plus 84, and then 4 times 48 root 24. Okay. Can we simplify by anything? We can simplify by 3. It will be 13. 84 is what? 2 times 3, 6, 24, 28. If you divide by 3, it will be 16. Okay, can we simplify more? No. Now, if we raise the power of 2, let's calculate this part first. 13 times 23. It will be 339, 326, 23. So it will be 992. 299 plus 28, which will be what? 8 plus 9, 17, 2, 327 left hand side. Now for right hand side, 4 times 16, 64, root what? Root 24. Now we can raise both sides to the power of 2, 327 squared, and 64 times 24. If you calculate left hand side, it will be this. Right hand side is 64 squared times 24. Now which side, if you calculate this, it will be 98, 304. This one is greater, so this one is greater, this one is greater, this one greater, this one greater, 39 over 4 greater. So 39 over 4 is greater, so B, this case is good. Now the problem wants what? A squared plus B squared plus C squared over 4. Let's write A squared plus B squared plus C squared over 4. A squared is what? 529 over 16. Plus B squared is what? 4. C squared is over 4. Now, if we multiply by 16, both numerator and denominator, it will be 64 plus 64 over 64. Okay. Now it will be what? 4 plus 4, 8 plus 9, 17. We have 1. 1 plus 6, 7 plus 6, 13 plus 2, 15. We have 1. 1 plus 5, 6. And over 64. And let's see the problem wants what? The sum of numerator and denominator. It says simplify P over Q. P plus Q is what? So here, P over Q, it is in the simplest form because it is odd and 64 is 2 to the power of 6. So P plus Q is what? Is 657 plus 64. 4 plus 7, 11. We have 1. 1 plus 6, 7 plus 5, 12. We have 1. And 1 plus 6, 7. So the answer of this problem is 721. Now let me tell you some problems similar to this one. We've considered how many ideas? Lagrange multiplier, I told you, idea 32, 33, factor theorem. Also, I think I told you replacement. 32 replacement, 33 this, 31 this. So 33 ideas. How many homeworks? 28 homeworks. So let me tell you some other homeworks. Homework 29. You can solve these 4 problems. They're from SMO, Singapore Mathematical Olympiad, without Lagrange multiplier and with Lagrange multiplier. Okay, to get good at this idea for finding the problems that we have a condition, like this problem of AIME. For example, it is condition and we want to find minimum of this, or this condition we want to find minimum of this, or we have this condition we want to find maximum of this, or for example, we have this condition we want to find maximum of these parts. Try these for homework. So I left 32 homeworks and 33 ideas. Okay, if you want to learn more ideas or want to solve more similar problems, as I said before, feel free to send message to my WhatsApp number in the description. Okay, thanks for watching this video. Bye.